Okay, we'll go ahead and get started. I think maybe what we'll do first is, since we see Dr. Henze on, Davin, did you want to go ahead and present your comments on chapters 5 and 6? Unfortunately, he wasn't able to participate yesterday, but he's here this morning online. So maybe we'll give him an opportunity to present his comments. Dr. Henze, are you on?
Hi, Aaron. Yeah, thank you.
Yeah, and also you're welcome to introduce yourself if you'd like for the EPA and the public.
Thanks, Leon. Sure, my name is Davin Henze. I'm a professor at the University of Colorado in Boulder in the Department of Mechanical Engineering and in the Environmental Engineering program. And my area of expertise is air quality modeling, the sources, transport, and fate of pollutants and greenhouse gases. And I was unfortunately not able to join yesterday, so I wanted to chime in with some comments on chapter 6, the relationship of deposition to air quality metrics. And I think I have some detailed comments, but maybe I'll start first with sort of an overall comment in response to the charge questions, which were between air concentration and deposition to be considered. Were the relationships technically clear and sound, and what are the CASAC views on consideration of key limitations and associated uncertainties? So in terms of this relationship between ambient concentrations and deposition, this is sort of my overall impression was, given that there's an overall need for more stringent standards, as indicated by the administrator's prior judgment that current standards do not adequately provide protection against adverse deposition-related effects, that the coupling or the suggestion to couple the primary PM2.5 standard of 12 micrograms per meter cubed to the secondary standard would be a tightening relative to where we've been, and would conveniently sustain the practice of mitigation of welfare effects via primary standards. And the concern is that reliance on PM2.5 concentrations as an indicator would lead to situations where potentially the wrong part or the wrong component of PM2.5 is reduced to attain the primary standards. And hereby I mean the wrong part, I mean a part not associated with reducing nitrogen deposition, especially as reduced nitrogen is an increasingly large component of reactive nitrogen deposition, yet ammonia emissions are not regulated. So scientifically, it would be more direct to target nitrogen deposition values themselves as an indicator, which is perhaps permissible within the Clean Air Act's definition of a level of air quality. That being said, I understand the approach being taken here and can comment more on the clarity and technical soundness of it. And the use of PM2.5 as an indicator of deposition is sort of put forth because at first it's noticed that concentrations of nitrate, aerosol nitrate, are not correlating well with the overall reactive nitrogen deposition. And there's a few reasons for this. But again, one of them is that there's contributions to ammonia and ammonium to reactive nitrogen deposition that are not present in a nitrate aerosol measurement, but they are present in a PM2.5 measurement. And so it's this incorporation of ammonia that on one hand is a little concerning because we don't have ammonia emissions regulations, but on the other hand is a benefit because you do start to incorporate that into the measure used for the standard. And if that's really sort of viewed as the beneficial aspect of this approach, there's a few places where showing a little bit more about ammonia and the relationship between ammonia and deposition would, I think, strengthen this chapter. So I have in my written comments a few specific ways that this could be done. One is, when looking at the nitrogen deposition, to separate between oxidized and reduced nitrogen rather than total in the analysis of nitrogen deposition versus improved sulfate, nitrate, and PM2.5 in the text on page 6.7, but also in figure 6.4, 6.5, 6.9. These are these plots of the histograms along the diagonal and the correlations, the scatter plots on the off diagonal. I found these matrices to be incredibly interesting and very helpful for the points that the review was trying to make. But they're also a little bit they're very dense and can be a little bit tricky to compare. You're trying to compare what is the model telling us versus what different measurement networks are telling us, and what are we learning about the relationship between PM2.5 and nitrogen deposition. So here are a few things that could help. As I mentioned, just evaluating oxidized versus reduced nitrogen would be useful in these plots. The modeled versus measured matrices would be much easier to compare if they were ordered similarly. This even applies to just a few rows across the measurement matrices where the orders of different species are swapped. So it just makes it a little bit difficult to intercompare across these figures. A useful addition, though, especially to the model matrix, would be including ammonia in the gas phase and ammonium in the aerosol phase as additional rows and columns for this matrix. Again, this would be useful, particularly if they also added total PM2.5 to the modeled matrix. I'm talking about figure 6.9, to help make the point that they're making with the measured matrices, to show that the combination of these would allow us to better understand the role that ammonia plays on PM2.5 as an indicator and in relationship to nitrogen deposition, because this contributes to the suggested use of PM2.5 as a standard. I have some sort of technical questions. There's some panels that seem to show two different regimes for the data, or two different ranges of values for the same quantity. For example, scales are quite different for the sulfur deposition, up to 50 on one panel on one matrix and only up to 12 on another, on the model plot versus the measured plot. So I'm wondering if they're just plotting sulfur versus sulfate, something like that. That could be, I think, clarified. The second main topic is the EAQM. And I appreciate the approach, and I can apologize for not being aware of how much this was discussed yesterday, but the review well demonstrates the value of comparing the EAQM measure to just considering concentration levels in an ecoregion in comparison to deposition. That being said, I do have several questions and concerns. EAQM is derived based on a few assumptions that are mentioned in the discussion of uncertainty but aren't tested. And I'd really like to see how sensitive are these relationships to, say, the 1% threshold for a site being considered representative. That seems perhaps low, but it's certainly, I mean, it is presented as something that's arbitrary a little bit. And so it'd be nice to see what happens if we change that. The time of the trajectories of only 48 hours also seem low, given the role of secondary species and PM with lifetimes on the order of days to a week. Again, these are mentioned as topics in the discussion of uncertainty, but I'd like to see some sensitivity evaluations of how these affect the results. The EAQM approach is based on meteorological trajectories that doesn't account for chemistry, sort of along the path between sources and deposition. And there can be some very interesting and sort of curious nonlinear relationships in that sort of fate and transport that aren't captured by just a meteorological trajectory. And so I think this should also be mentioned in the discussion of uncertainty and perhaps evaluative sensitivity studies. And then also a lot of the reactive nitrogen transport and deposition will be seasonal because of the seasonal nature of nitrate formation and of ammonia sources. Meanwhile, the EAQM definitions are based on transport patterns over the entire year. So that may not be indicative of the transport patterns during the deposition season, if you will. So this would be another thing to consider for sensitivity calculations. In figures 6, 14, 15, 17, 18, they show that the relationship for sulfur deposition is pretty weak as you get below 5 kilograms of sulfur per hectare per year, which is the regime that we're in now. And so while the indicator seems to be a good way of sort of explaining the past situation and past trends, I'm not sure how well it does sort of describing our current situation. And then lastly, figure 6.25, I found to be it's remarkable and honestly a bit surprising. Just the high degree of correlation between the EAQM PM2.5 and reactive nitrogen and total nitrogen deposition, again, it well supports the point that, or the suggestion that is being made about using this as an indicator, but just the lack of scatter in this plot and the degree of correlation was, I think, astounding to me. So that's why I would like to see how sensitive is this to some of the uncertainties that are mentioned previously. What happens if you break down the deposition component by oxidized versus reduced? I'd like to dig into that one plot a little bit more, because it is a really, really key plot for forming the basis of the suggested path forward. So in the rest of my written comments, a few small editorial corrections and things to point out. But yeah, thank you for taking the time to reopen discussion on chapter 6 here, and appreciate the opportunity.
Thank you, Davin. Is there any comments by anybody on the panel? Any follow-up? You hit on a couple of topics that we spent some time on yesterday, particularly your last one on figure 6-25. Bob.
Yeah, thank you, and thank you, Davin, for that. It's a great summary. I found that really, really useful. A lot to think about there, and yeah, many of us commented on that particular figure yesterday. It's astounding, as you say, and it's worrisome. If it's really true, that's great, but it seems like there could be some sort of weird autocorrelation or something in it, and so we need to be very cautious about it. But I really appreciate your thoughts about breaking out the reduced versus oxidized ammonia, and also the gaseous phase ammonia versus the particulate stuff in there. And I think that'd be extremely helpful, particularly if we go down this track of using PM25 as the metric to regulate. So thank you for that.
Any other further comments on chapter 6? So let's see, do we move to chapter 7? Do we wait? Want to go ahead? All right, I guess we'll have EPA do their introduction then for chapter 7.
Okay, well, good morning again. Good. We did some homework following on the request of Dr. Pinette Gonzalez, good morning, to try to put into some slides, like in a nutshell, kind of how we walk into the conclusions of chapter 7. And so I'm going to try to go through these, and hopefully this will help a little bit with some of the discussion on chapter 7. I also hope maybe it will help a little bit on some of the discussion on chapter 6. I think it might help in understanding exactly what we are extracting from those findings and using it for policymaking to try to understand what the pressure points maybe are on some of those issues and uncertainties. So, okay, so let me start with this slide. So I'm not going to go through all of this in detail, but I want to explain it in a nutshell, which is what we're trying to do is we're trying to start with this gray box. And if I think about this gray box is incorporated mainly in chapters 4 and 5. And we're trying to look at that information, the scientific information, the quantitative information, and we're trying to extract from that as best as we can what are air quality deposition levels for nitrogen and sulfur that we feel like we have confidence in being associated with adverse effects. And in our judgment, what are the concentrations at which that we think we want to protect, we want to be at or below. And so we're looking at that information and we're trying to extract from that what we think those deposition levels are that we want to try to target. And as with anything in policymaking, there's a range because there are decisions that are made that underlie what those target levels of protection should be. And so we come out of chapters 4 and 5 with generally a range. So, and I'll step through kind of what we feel like we extracted from that information. So then we move over to this yellow box, yellow circles. And these yellow circles are really what we're trying to take out of chapter 6. Okay, so it's a difficult problem. People have been working on this for years. I don't want to give any illusions that we think that somehow in this chapter 6 we have solved this problem, but we are trying to come out of chapter 6 and extract out general relationships that we feel like we can have some confidence in, particularly targeting some of the issues that we really struggled with in the last review, which is trying to have some confidence in how a setting of a standard will have some control over deposition. So we're trying to come out of chapter 6 with those types of relationships, and so we're trying to pull the gray box, the gray circles together and the yellow circles together, and we're trying to look at those two relationships to arrive upon policy conclusions as far as how a range of potential standard options could help us target levels of protection of deposition based on the evidence. So that's the conceptual model that we're working under. So the next slide. So I have a couple slides that are trying to extract the information I was talking about within the gray or silver circles. And there is a lot of information in chapters 4 and 5. And so it's somewhat insulting to try to distill it into two slides, but at the end of the day, we're trying to come up with a range of deposition values that we feel like are appropriate to target. And so let me start with the aquatic acidification aspect of those analyses. Particularly, it was in sections of chapter 5, section 5.2, and of course the appendix. So the conclusions that we're drawing out of that information: sulfur deposition has declined significantly since the previous review. We've talked about that a lot. In the analyses that we did, we looked across a range of years. I think it was like 18 or 19, almost 20 years of data. And what we found is that under recent conditions, water body sites were estimated to be receiving deposition in excess of their critical loads, but very few few water bodies are estimated to be receiving deposition in excess of their critical loads for relevant ANC target levels. So when we look at that information, we look at trying to establish what does this information show us in levels of deposition targets. We see at the upper end of the range, we feel that around 13 kilograms of sulfur per hectare per year. We see that about 90% of the water bodies across the ecoregions are estimated to achieve ANC targets at 20, 30, and 50. We looked at that range in 80, 73, and 65% of the ecoregion time period combinations. So we feel like 13 is a good upper end of the range based on that information. And then at the lower end of the range that we feel is relevant, we found that for the analysis that the sulfur deposition estimates at or below 5 kilograms of sulfur per hectare per year, found that 90% of the water body ecoregion estimates to achieve the ANC targets at or above the ANC targets of 20, 30, and 50 in 96, 92, and 82% of the ecoregion time combinations. So that's the information that we're extracting from the regional from the eco level, national level analysis. So if we move to the next slide, we also looked at case study areas. So as we discussed in the REA plan and was included in the policy assessment, we drilled down specifically to case study areas, and we did look at a variety of changing emissions, as particularly focusing on meeting the secondary standards and what they looked like. And what we found is that sulfur deposition estimates of 9 to 10 kilograms of sulfur per hectare per year, but all sites on average achieve an ANC at or above 50. And then similarly, looking at 6 to 9 kilograms per hectare per year, 70% of sites achieve an ANC of 20. So again, so this is falling within that range of 5 to 13 that we're kind of extracting out of the aquatic acidification information. So we also looked at terrestrial effects information. Of course, as we've discussed here, there are there are challenges because we have a historic deposition pattern that is affecting the information that we're looking at. And that's all discussed, of course, in these chapters. But if I summarize it in a nutshell of what we are pulling out of there, when we look at the quantitative information from the evidence, including the studies of associations of sulfur and nitrogen deposition, and tree growth, survival, species richness of herbs and shrub communities and lichens, and this is generally described in the appendix 5B and section 5.4. We see this pattern of sulfur that suggests deposition from 5 to 12 kilograms per hectare per year, maybe your appropriate range of target based on terrestrial information. And for nitrogen, it's a little bit more difficult to extract that information, but we felt that a range of 7 to 12 may be appropriate range of potential interest. And I just want to say, I know we talked quite a bit and with respect to your comments on the nitrogen impacts on aquatic systems. And so, of course, it's not in the document now, but if that is a comment that CASAC would make, then we would be going back to the document and improving upon the nitrogen discussion with respect to the aquatic information. So, okay, so moving to the next slide, thank you. Okay, so that in a nutshell was kind of what we were trying to extract from chapters 4 and 5. And then when we look at chapter 6, again, this is a really difficult problem. And we did what we felt like was a lot of different approaches to try to tease out some of these relationships and get at this issue of how one looks at how a standard would control deposition, either from transport, looking at a standard set as it normally is at monitors near sources and how that impacts transport deposition, as well as what if you instead set a standard at a monitor in a class 1 area, for example, that is, you're looking less at transport and more at, quantifying the problem in its place. And I want to say that when we extract from chapter 6 the conclusions that we think are most supportive and most useful and most relevant in chapter 7, what you will see is we don't use the EAQM necessarily in a predictive manner. So we're not necessarily going in and saying, okay, let's draw a line, and then this tells us what the standard should be. I think we recognize, that the methodology is useful in characterizing relationships, but not necessarily without its limitations. We recognize that there's scatter. And we recognize that a good amount of that scatter has to do with the fact that we are pulling from a large amount of time periods and that emissions trends and sources change, right? So what you'll see is that in recognizing that, we end up looking a lot more at recent conditions information in thinking about establishing relationships in how a standard might relate to deposition. So, so just to kind of go through some of the conclusions that we feel important to extract from chapter 6. So with respect to SO2, we felt that the chapter supported that reductions in SO2 emissions do result in sulfur deposition changes and reductions in both the gas phase SO2 as well as the particulate phase SO4 sulfate. We felt that, generally speaking, we found a positive linear correlation between deposition estimates based on the trajectory-based analysis and the SO2 metrics that we looked at. And of course, we looked at 2 different metrics, one that mimicked the current form of the standard, the second highest annual 3-hour SO2 daily max averaged over 3 years, as well as one that would mimic more of a cumulative impact, so annual average SO2 averaged over 3 years. We felt that the information showed that both metrics indicated control of SO2, with the annual average showing a stronger correlation with the deposition, which we felt made sense given that deposition is more of a cumulative impact that we're looking at versus more of a peak impact, which is the first metric is more relevant for that. And then as many of you have noticed, we also called out that there's substantial scatter when you looked at very low deposition values, below 5 kilograms per hectare per year, for example. We felt that there was enough scatter there that we weren't really sure on how best to interpret and how best to control deposition to lower than these levels. And then the NO2 and PM2.5, the trajectory analysis did examine the relationships between nitrogen deposition and annual average NO2 and PM2.5, looking at 3-year average metrics, mimicking the standard for PM2.5. We found that there was correlation between the NO2 metric and the nitrogen deposition, but that correlation was somewhat low. And then I know that we've noted this figure multiple times. We did find that there was strong correlation between the PM2.5 annual metric and nitrogen deposition. I take to heart the comments from CASAC and the need to look a little stronger at some of those relationships with some additional analyses before anything was definitely cemented on those conclusions. So for the next slide, one of the things that I mentioned is, in addition, we looked at the relationships, not transport so much, but relationships in a class 1 area. So how the air quality metrics would relate to that deposition in those areas. And generally, we found that in rural areas, the sulfur deposition seemed to result primarily from sulfate, and in the West, a little bit more from SO2. And we found that there were multiple different indicators that are measurements that correlated with that deposition. For sulfur, improved PM2.5, improved sulfate, and total sulfate at the rural CASAC sites all seem to have a correlation and potential for predicting sulfur deposition in the class 1 areas. And then with respect to the nitrogen deposition, similarly in the rural areas we looked, and the nitrogen deposition was fairly well correlated with air concentrations of nitric acid as well as inorganic nitrogen. We looked at potential measurements that correlated well. We found improved PM2.5, improved approximated inorganic nitrogen of PM2.5, and inorganic nitrogen at the rural CASAC sites all had potential for predicting nitrogen deposition in these areas. Okay, so now to chapter 7 finally. So when we looked at extracting those sets of information and how they fed into our conclusions, we'll step through kind of how we saw that fitting together. So we felt that for sulfur, that SOx had the clearest ties to deposition-related ecosystem acidification through the appreciable sulfur deposition that's happened over many decades. And we felt that the understanding of the role of SO2 was very strong. With regard to the 3-hour average SO2 standard, not to be exceeded more than once per year, which is the existing standard, we felt that the recent conditions information tied to that range of deposition that we were looking at, we felt that a range of 200 to 400 may provide the control of that sulfur deposition in that range of interest, would maintain at or below. With regard to the annual average SO2 standard, again, we felt that this correlated better with the sulfur deposition, given the cumulative impact. And we found that in looking at recent information, again, tending towards putting emphasis on the recent information, given some of the emissions changes and some of the bifurcations and some of the analyses that we saw that gave us pause on using the complete trends to establish the relationship. We found that the recent time information supported that that sulfur deposition was maintained at or below 5, when the SO2 concentrations at the monitors were below 22, and the majority of monitors were below 10. So moving to the nitrogen, so multiple factors affect the nitrogen deposition relationship with NO2. So chapter 6 analyses did indicate that there seemed to be a relationship between nitrogen deposition and PM2.5. And so if we utilize that relationship and utilizing the PM2.5 annual standard as a way of providing control of nitrogen deposition, in addition to providing some control of sulfur deposition, we felt that the information supported that a level of 15 to 12 would provide that type of control. Additionally, with regard to NO2, we looked at the information on historic concentrations and impacts on lichen communities and the potential for the relationship with direct contact to HNO3. And what we found based on that historical information, that it would be appropriate to consider a revision to the NO2 annual standard, looking at a level below the current standard, which is set at 53 ppb, and perhaps down to as low as 40 ppb. And I will note this doesn't, these conclusions don't reflect some of the comments that CASAC made yesterday with respect to assessing the nitrogen impacts, some of the additional impacts on aquatic systems. So, okay, last slide. So in pulling this information together, this table is meant to capture the policy options, the range of policy options that Chapter 7 was conveying. And again, we're looking at the information that's coming from Chapter 4 and Chapter 6 and pulling that together and trying to provide a range of policy options that could be considered. So with respect to SO2, we found that it may be appropriate to retain the current standard to address direct air-related effects. But in looking further at the deposition-related effects, we felt that there was a strong base of evidence for revision or for a new standard and potential revision depending on the standard that was chosen. And we looked again at the two metrics. So one approach could be to revise the current standard, leaving the form the way that it is currently, and revise the level to 200 to 400. An additional different approach to this that was included as a policy option in Chapter 7 would be instead to establish a new standard and potentially replace the old one with a standard that looked at that had the form of an annual averaged over 3 years, and that the level would be set to 10 to 22 ppb. So moving to NO2, we felt that there were that the NO2 standard relied on more heavily on some on policy choices and decisions related to those impacts, and so we felt that it would be appropriate to consider retaining that standard with respect to impacts from direct air. However, we also found, as discussed in the last slide, that it would also be appropriate to consider revising that standard, reducing the level of that standard below 53 and to as low as 40. We also looked at deposition-related effects associated with nitrogen deposition, and we found that given the relationship with PM2.5, that it may be appropriate to consider revision to the PM2.5 annual standard to target nitrogen reductions. And with respect to the PM2.5 annual standard for that purpose, again, it was the Chapter 7 discusses reductions in the level to below 15, which is the current standard level, to as low as 12. And then it could also potentially be appropriate to consider retaining, given some of the uncertainties in using a PM2.5 standard to try to target reductions in sulfur and nitrogen deposition as well. Again, we're trying to put a large range of policy options on the table that we feel are supported by the science. And then for the other PM standards, we felt that it was appropriate to retain those and to focus on the annual standard if the PM standard was used for reductions. And then at the very bottom here, this is a reference to the analysis in chapter 6 that looked at could one target a standard in a more rural area and look at components, for example, of PM or different nitrogen and sulfur related components. And we found that there was correlation and that this could be a potential policy option that could be explored. I think we also noted that this would also mean the need to establish federal reference methods on how one monitors those pollutants, measures those pollutants, as well as assessment of whether the current network was sufficient for doing that. So I think those two things would need to be turned over if that policy option was embraced. So, okay, and I think that's it. So that was helpful.
Thank you for that. I think I first open it up for any clarifying questions or comments by anybody on the panel. Bob Haworth, raise your hand, and then Charlie next.
Yeah, okay, thank you. That was very helpful in thinking. A couple of points I just picked up on. In one of your slides, you suggested that based on the terrestrial effects, that you start to see deleterious effects between 7 to 12 kilograms nitrogen per hectare per year. I believe that was your statement. I just want to point out that, from my perspective, working on watershed fluxes going to aquatic ecosystems, that's a pretty high depositional input. We definitely see effects in aquatic systems at lower deposition rates than that. So I would question whether that's really going to be protective or not. And but also, I thought it'd be interesting to try and relate that to the figure 625 that we've been discussing. And so I just took a look at that. And in fact, there's a one-to-one correlation between the micrograms per cubic meter and the kilograms nitrogen per hectare per year in that figure. So that if we were to agree that the standard should be less than 15 micrograms per cubic meter, maybe down to 10 micrograms per cubic meter, that would correspond to a deposition rate of 15 kilograms and maybe down to 10. So higher than what you have indicated we see deleterious effects in forests. And again, I would suggest that even that isn't protective enough for the aquatic systems. Thank you.
All right, thank you for those comments, Charlie.
Deidre, did you have a response to Bob? Did you have your hand up?
I think we'll wait and perhaps clarify later. Yeah.
So I had just a procedural question on how you envision this playing out. So you have given us pretty wide, pretty broad approaches to this. So do you want us to comment on that? And are you envisioning that those would be narrowed? I would think that the administrator would, I mean, I have no idea what the administrator thinks, but I would think that they would want a tighter ranges, because these are quite broad and quite varied. We're talking about sulfur, nitrogen, PM. So there's a lot on the table. So could you, I realize this is some give and take here, but could you give us some ideas on sort of how you envision the end game going on this? Do you want us to give you specific recommendations on how you might tighten that up, or do one versus the other or all. So I just like to hear your perspective on that. I mean, we're going to tell you what we think anyway, but I'd like to sort of hear what you think in terms of what you see the process going, if it could go the best path that you would like to see. So.
Yeah, no, I appreciate that question, actually. So yes, so we try to come to CASAC with a wide range of policy options that we think are supported by the science. And we look to CASAC on, whether we got the appropriate range, right? And often what we get back from CASAC is information on how strongly supported the top end, the bottom, the middle. I mean, it's as you know, I mean, as we generally experience, sometimes at the upper end and the lower end, there are greater uncertainties. And so and maybe in the middle, there's you feel that there's more confidence in the option being put on the table. And so we're kind of looking to CASAC on what do you think what do you think the strength of evidence is, right? So often CASAC will reply, back with like, well, we think this range is supported, and we think the upper end is supported if you put weight on X, Y, and Z, and are okay with these uncertainties. And we think the lower end of the range is supported if you put weight on A, B, and C, and if you consider these uncertainties. And so but we think that, I mean, generally that's the type of advice that we look to CASAC for, the scientific merit of the range. So, and I don't necessarily think that we look to CASAC to need to narrow. I mean, if you think it should be narrowed, then narrow, because, you say, well, this is not supported by the science, or this is not supported by the science. I mean, that's fine too.
Okay, that's very helpful. So a couple of observations that I have that I think you should think about, and one is I brought up yesterday that you have a tremendous reliance on these steady state models, and I think it was a great analysis. I know Jason put in a lot of time. It's very valuable. People were very appreciative of those efforts, but a steady state model has very simplifying assumptions. It is not time dependent. And so you really are, what you're doing is you're getting a result at time infinity, okay? I mean, that's a very long time. Okay, so there are other studies, field studies, and dynamic modeling that would help put that in context. So it's an extremely conservative analysis if you're assuming steady state conditions, because steady state conditions are not the reality. In fact, soils are changing, and there are effects of those that are not reflected in surface waters. So it's really sort of a worst case scenario, or best case scenario, I guess it would be. So it's an overly optimistic projection. So I think you're taking to rely heavily on that approach for sulfur. You're taking a very conservative approach, and I think you can easily defend pushing it down further. If you look at the recovery of surface waters, there's great time series data on the recovery of surface waters. In the Northeast, sulfate is going down, systems are recovering, albeit not as fast as might be projected because of the loss of cations and the changes in soil conditions. But in the Southeast, that's not the case. Those sites have accumulated a lot of sulfur. They're bleeding out that sulfur. That's greatly delaying the recovery. You're not talking about something that's happening over periods of years, but rather decades to centuries. So I encourage you to think about the time scale of recovery, which you've completely ignored. And I think that that's a very, very important consideration. And I think, similarly with nitrogen, you've targeted NO2, oxidized nitrogen, but we are experiencing ongoing impacts from reduced nitrogen, and those are going up and are probably going to continue to go up. So it seems to me, again, that would warrant us. You can control oxidized nitrogen, so it seems to me if we're concerned about nitrogen effects, we should go the extra yard to control as much as possible, because we don't have controls, or very limited controls, on reduced nitrogen, and that's becoming a looming problem. So I realize there are different sectors, different sources, whatever, but ecosystems don't understand that. They're just receiving nitrogen and they're impacted by that nitrogen. So I think that that could cause you to be more aggressive in terms of on the nitrogen side as well. So I'll shut up and let others talk.
Other comments, any feedback from EPA on that? Judy, did you want to say something? You wanted a different topic? Go ahead. I didn't see them really eager to respond, so.
Yeah, I would, that the policy assessment suggests the return of 24-hour PM 2.5 24-hour standard, as it was not assessed as most relevant metrics for nitrogen or sulfur deposition. I kind of disagree with that. I would like to recommend EPA to lower the secondary PM 2.5 24-hour standard to 25 microgram cubic meter. This is in line with the CASAC PM panel suggestion of 25 to 30 microgram cubic meter. As the control human exposure study being used for the PM and the risk assessment use PM assessment may not capture areas with wintertime stagnation, the use of residential wood combustion, and the springtime or summer fall time wildfires that's happening now for the Canadian fire, where annual standard is less likely to be protective. So I think it's important to also consider this, the 24-hour standard. This is also in line with the Park Service recommendation, well, that 25 microgram cubic meter is pretty much associated with the visibility index called 25 deciview, where the preference study also showed that most people with a landscape feature, that means from the point A to point B, the side path you can see is about 40 kilometers, that most people, 50% of the people find that level to be acceptable to most general public. So that I also feel that more, for the more analysis may be warranted for areas with 24-hour PM 2.5 standard, like such as during the fire event the last few weeks, Donna probably suffered there, right? Yeah, that when they exceeding 24 microgram cubic meter, we like to see the relationship with sulfate and nitrate, because sulfate and nitrate account for at least 1/3 of most of the area, but sometimes it's even more of the PM 2.5 mass, which is responsible for a pretty big chunk part of the particle light scattering, which means that obscure our visual range. So that may be worthwhile to look into it. So for the future review, then we have a better idea on this. Yes.
All right, thank you, Judy. Praveen.
Thank you. I have a clarifying question. I don't have the expertise in this, but I remember, Charlie, you talking yesterday about looking at the deposition-based standards and not concentration-based standards. That's one. And maybe you want to say something more here. And number two, reduce nitrogen. The ammonia inventory or emissions they look different across the country, Midwest, North Carolina, and so on. So would you think about a reduced nitrogen standard on a regional basis, or that would be some kind of a national standard? I'm asking Charlie, I don't have the answer.
Question for Charlie.
Well, I made my comments about deposition, and I think Davin sort of suggested the same thing, that I think it's a cleaner way to go, and I'm not convinced that you couldn't do that but I'm not a lawyer. So, but anyway, we discussed that yesterday. So I think that that would be a cleaner approach. And then concerning these regional standards, I have no expertise in that. I think that there are, states could potentially implement things if they were concerned about, PM or effects, but I don't have any expertise whether that's been done. I know there's some efforts to try to reduce nitrogen from CAFOs and other operations, or at least some regions are looking into that, but I don't know the extent of that.
Thanks. And one more thing about deposition standard, you did make that point yesterday, but I was wondering, would that point be brought in today in this discussion right after UPS presentation?
I'm not driving the bus here, I'm just.
Well, I'm not either.
Yeah, I think it's worthwhile considering, if not now, then in the future. I think it's, I think there are issues, as we've talked about, in terms of relating concentration to deposition. There are good reasons why there's a lot of scatter and variability. So I think that if you could do a deposition-based standard, it would be a cleaner way to go. It would be a more direct measurement. We have very detailed monitoring systems through NADP that have been in place for a long time. We have some confidence in CMAQ for estimating dry deposition, which presumably is continuing to improve. It seems to me it's a better way to go in terms of evaluating what the spatial variability and the difference in landscape conditions concerning sensitivity to inputs. So to me, it's cleaner, and so that's what I'm suggesting. So, and I've suggested it over years, so it's not the first time I brought this up. So.
And he will write something for our consensus comments, so we will definitely comment on this point. We could consider further whether we need to integrate it into this chapter as well. Stephen has his hand up.
Yes, thank you. I came in a bit late, so some of my apology, some of these questions may have been addressed, but let me try to get some clarification on them anyway. I think yesterday we had the question raised as to whether there can be a deposition standard under the current legislation, and I think the answer was a resounding no. It has to be an atmospheric concentration standard. Is that correct?
I think that's what we heard from the OGC. That doesn't mean that we can't provide our scientific advice that we think this is important and ask them to go back and look at it again. So I think both can happen. I mean, both are should be considered.
Okay, thank you. Yes, I'm not suggesting that we can't make a recommendation in that direction. I'm just asking with respect to the current legislation, and I think the answer is a resounding no.
I think that's what we heard as the interpretation of the current OGC view at EPA.
Okay, good. Thank you. My next question, and I think that was just addressed, is do concentration standards have to be uniform across the entire country? And I think the answer to that is yes.
EPA is shaking their head yes. Maybe you want to say anything more?
Yes.
Okay, just I didn't quite get that, but the answer is again yes.
Correct.
Okay.
It is
Okay.
yes.
I'm seeing the nodding of the head, so that I'll take that for the answer. Okay. My next question is, so what's the status of I won't use the word compliance, but observations of exceedances? Are we is the country basically in compliance with those standards, or are we exceeding them, and by how much and how often and where?
So chapter 2, I think, takes that on. don't know if I don't know if it's worth dragging or going through that in detail now, but I guess I will say a couple things. One, just if you look at the standards, the current SO2 and current NO2 standards are being attained, and the current, generally speaking, in the current PM standards, there are areas that are not attaining those standards. And you can see geographically more detail in chapter 2 because that information is laid out there. But I guess I would also say it's not really relevant. Like, that's not really what we're assessing, is what, you know, is being attained or not being attained. It's what's the target level of protection that we need to be providing with the standards. So it's a different focus.
So I didn't quite get all of that, but sort of my question is, are the atmospheric concentration standards, the secondary standards that are in effect now, are we by and large meeting them, or are there areas where there's substantial exceedances?
I think the answer that Karen gave that's most relevant is that that's not the right question for us to be asking right now, that we should be focusing on what's the target of protection and not what's happening currently in terms of meeting them or not.
Let me try to get to why I'm asking that question. If the answer were yes, they're by and large being met, then my next question would be, with respect to possible harmful effects on ecosystems, with deposition exceeding a certain threshold, my question would be then with regard to measurements, and I'm looking, for example, at figure 6, 12, and 13, and I'm looking at the red points, which are sort of more or less current on those. We're by and large, we're staying below 5 kilograms of sulfur per hectare per year in the current set of measurements that are represented in that figure, which are essentially measurement based, and pretty much below 10 for the nitrogen. And in that context, if the current standards, concentration standards, are being met, then these are the depositions that are resulting from those current concentrations. And then the question would be, are the sort of the 5 and the 10 for sulfur and nitrogen respectively, are those sufficiently protective of the sensitive ecosystems? And if the answer to that is yes, then I think we're done. We say stay where we are. We're not having major exceedances. We're staying below deposition thresholds of concern, and keep the system as it is. If, on the other hand, we have exceedances that are substantial, then getting those areas into compliance should bring these numbers down. And then the further question is, are the standards of 5 and 10 for deposition standards, deposition rates, is the ecosystem community think that those numbers are too high, or are they satisfied with them? If they're satisfied with them, again, we're done. So that's the thrust of why I'm asking about current exceedances.
Thank you. EPA, did you want to follow up?
Yeah, so yeah, let me see a couple of things. One, I just want to point out, just to make sure that we're all clear, when we are talking about these deposition levels, we are talking, the spatial scale that we're talking about is a median across the ecoregions. So I just want to keep that in mind. We are recognizing that there's variability across an ecoregion, but we are looking at relationships in controlling to a median. So I just want to point that out, because I feel like we, you know, I hear you, and that there's variability and that there are higher impacts and lower impacts, but we're looking at a median. So let me just say that first.
Fair
yeah, just to clarify for several questions. And then the second point I guess I want to make is that when we look across the 20 years of information and we see area, like when we look in the past, I take your point, which is like, if you're looking now and you feel like you're okay with that there are not impacts of concern, then maybe setting maybe the maintaining a level around the current levels is appropriate. I guess I would also say when we look in the past and we look for example, 10 years ago, when many of the standards were being met, and we feel like there are still, especially for sulfur, effects of concern occurring, we feel like we have confidence in making the conclusion that the current SO2 standards are not adequate. And so one of the conclusions that we're putting forward is that it would not be appropriate to just leave that alone, even if current conditions are below those standards, because there's nothing that says that they can't go back up. I mean, so like we feel like it's appropriate to think, and it's appropriate within the context of the Clean Air Act, is to think about what is the target level of protection and what's the standard that's going to provide that target level of protection. Even if current conditions, I think current conditions shouldn't necessarily dictate those changes or not. So that's helpful.
Well, thank you for that. In any event, I would like clarification, maybe not right now, to my question as to what extent the atmospheric concentration standards are being complied, that regions are in compliance with those, as opposed to in exceedance, because I think putting that together with the red points in figure 6-12 or for the nitrogen 6-13, together with threshold standards for ecological damage, I think that might be an approach to saying, okay, we have to roll back the SO2 standards to get a lower deposition rate, or we have to have better compliance. But I do think that that's a kind of an empirical approach. Here you've got the measured depth, you've got the amount that's coming down, and if we're above a threshold, a damage threshold, then we got to roll things back, and if we're not, we stay where we are. So that's the thrust of my question, and I think it is. You're saying it's out of bounds to ask whether current standards are being met or not. I think it's in bounds.
Thank you. I think Deidre wanted to follow up, and then Rich.
Sorry, just to make sure it's clear, when Karen says the standards are being met, they may be met, but be well below the standard. So in the more recent times, perhaps the concentrations are such that they're well meeting the standard, versus 10 years ago, 15 years ago, they were closer bumping up against the standard. So both situations were meeting the standards, but conceivably allow much different deposition. The deposition estimates we have for those two different time periods are quite different. And so it's not a question of whether we were meeting the standard alone that matters, because we may have been, just meeting it may not have been okay, but being where we are today may be okay. And that's not at the standard, that's below the standard. So perhaps the standard should be different. Okay. Is that useful?
That is helpful to me. Thank you.
All right, thank you. We'll move on to Rich.
Yeah, I was just going to make that same response. Yes, we are in attainment of both the SO2 and NO2 standards. And for NO2, we have been for quite a long time and by a really large margin. The other thing I wanted to ask, though, as a point of clarification, this concept of the need for a nationally uniform standard. I might be misremembering the aquatic acidification index, but to me, it was a standard that actually had this ANC indicator that incorporated the inherent sensitivity of the local ecoregion. So in one sense, it was a nationally uniform thing, but on another sense, it would have required highly variable aspects of exceedance. So that is something that's already been done. And so if there were a way to incorporate in this review some consideration of the inherent different sensitivities, like you had different thresholds for east and west for these things, if it were, that's not completely off the table, or is it?
Either way. I was just gonna say, we do describe the AAI in chapter 3 and try to describe what you're getting at, in that it is complex and involves an equation that has various inputs. Some of those inputs are region specific, but the aspect of it that was considered to be the standard was uniform. And so that was the construct that was put forward at that time and associated with the conclusion that we were not quite sure what level of protection we would achieve by meeting that across the country. And that became the driving problem in utilizing
it. Further clarifying questions, we will go through the assigned individuals. Judy.
Yeah. Just wondering, follow up on Stephen's figure 6-12 and 6-13, that if we're looking at so far and the nitrogen deposition of 5 to 10 kilogram per hectare year, that really associated with most recent year, that means 2014 onward, will be less than 8 microgram cubic meter of PM 2.5 mass. So seems to me that lowering the secondary annual standard from 15 to 12 is not really associated with those nitrogen deposition fact that 8 to 10 microgram cubic meter, like we propose for the PMX for the primary standard, seems to be more appropriate. I'd like to see EPA's comments on that.
So you're asking for those comments now? Yeah.
So maybe you can clarify, you're looking for a comment on.
Yeah. So you recommended 12 from 15 to 12. And I felt that doesn't seem to be in line with the deposition figures and others. Seems to be, for most recent year, the last 10 years, the 10 seems to be more appropriate than 12.
Which is 10, or you said 8 earlier?
8 to 10.
8 to 10.
Very good, Vivian. Yeah.
Yeah, I mean, we could pull up the information from chapter 2 on, but PM2.5, I mean, I guess I would not say that, in my understanding, most of the country is not at 8. I think it's, I think one could say that many areas are attaining 10, if that's your question. But of course, there is quite a bit of variability across the US.
Okay. Or were you talking about what the country was attaining, this issue we talked about before, or were you talking about?
I'm talking about the deposition relationship with the PM 2.5.
Right, and so the figure I think you and others had mentioned was 612 to 613. What I would suggest maybe 626 might be irrelevant if I remember correctly. Yeah, so that's looking at nitrogen deposition on the Y as a function of the annual average PM fine.
Yeah, well, that's nitrogen. Yeah, that's right.
And that's right from that's utilizing the concentration at the regulatory monitors on the x-axis, and then nitrogen deposition median in the downwind, so to speak, ecoregions. Perhaps that's a better focus.
So your 15 is based on the figure 24 and 26. I mean, your 12. But anyway, it's probably something to, well, worthwhile looking at it.
Next up, Davin has his hand up.
Thanks. Yeah, I guess just to chime in on this. Sorry, I'm getting a very slight echo. To chime in on that, when we go back and look at chapter 2 and figure 2-38, we see the regions where the nitrogen deposition is above 10, the hotspots that light up. And then if we scroll back to figure 2-27, we see the regions where current levels of PM2.5 would be at 12 or above. And there's very little alignment, right? The areas that are currently above 12 are some spots in California, whereas all of the sort of hotspot areas in the Midwest and Atlantic coast are in areas where the PM2.5 levels are, as Judy mentioned, in the 8 to 10 range. And so I would like to know why the bottom threshold considered at the moment is only 12 for the PM2.5 annual average.
I'm sorry, we missed what was the first figure you were comparing. You said it.
2.38, that's the total nitrogen deposition from TDEP.
Which is on page?
That's on page 2-43 or PDF page 75.
2-3. Total nitrogen, okay.
In comparison to figure 227, which directly answers Stephen's question about where we are right now in terms of attainment of the annual PM2.5 design values. That's on page 2.31, PDF page 67.
Sure. We haven't looked at like scatter plots of this sort. I mean, I think you're instinctively visualizing in your head essentially sort of a plot of the one versus the other, right? And I don't believe we've looked into that at depth. It may be something worth doing. I'm not sure.
Yeah, I mean, that would be useful. I mean, we see from the specific ecoregion sort of long-term trend analysis that there is a correlation between PM2.5 and nitrogen deposition, but just in terms of what parts of the country are going to be impacted by this change from 15 to 12. You can see from figure 2-27, it's a few spots in California, whereas what parts of the country are impacted by levels of nitrogen deposition that are of concern for adverse welfare effects. That's all these areas where the current levels are, as Judy mentioned, in the 8 to 10 range. And so why is the bottom threshold that's being considered here 12?
Oh, sorry. Yeah, no, I appreciate that comment. I think we were looking at them together, but I think your points are taken as far as correlating with the nitrogen and the PM2.5 hotspots. So,
Stephen, is your hand up fresh or is it leftover?
I put it up again.
Okay, then please go ahead.
Okay, I give me a second. I had scrolled up to those figures that Davin was referring to, but I want to go back to the figures I was just looking at, which were in 6, and I guess that precedes the appendix, I believe. Give me a second, please. I'm sorry.
Sure, no problem.
There was reference to figures in not what Davin was speaking to, but the previous speaker was making reference to 628, for example. 626, 625. And I guess for clarification, those are called estimated. And I would ask, just by way of clarification, what is the means by which those quantities are estimated?
It's the TDEP. It's the TDEP surface of deposition that's estimated. It's the fused deposition and air quality modeling surface.
So these are basically estimated on the grounds this is in some way very close to measurement, as opposed to that high split model we were talking about yesterday.
Yeah, so the deposition estimates here from the TDEP field, which are a combination of observed data, observed wet deposition data where available, melded with or merged. It's a hybrid data set with CMAQ model results for dry deposition, and it's described in, I believe, section 2.5, sort of the methodology there. Now, how we that's the y-axis in those plots. The x-axis, I'm looking at the right plots, are where the EAQM comes into play, where the trajectory modeling comes into play as to when we look at the sites of influence. That's the x-axis, which is then compared back to the TDEP estimated deposition data.
Yeah, okay, thank you for that clarification. I tend to be much more confident in observations and in quantities that are much closer to observations. That's why I was calling attention. I can't quite find the figure right now, but to the earlier I was calling attention to those figures with the red and the blue points, which to my thinking are much closer to observation than these ones in the 627, 628 series. Is that an accurate assessment on my part? That the figures in the data in 612 and 13 are much closer to observations than the ones in the 626 series?
They are also based on TDEP. However, they are at the class 1 sites. So it's a limited subset. So generally speaking, in the TDEP data, as you're closer to sites, particularly in the dry deposition, or excuse me, in some of the analyses that we've done suggest that TDEP data are closer to observations in those, in the space where you have the observations. Model influence is less there, in places where you get away. So it's kind of a complicated answer. The data themselves in 612 and 613 are TDEP, but to your larger question, they may be more representative observations than, some site which is relying more on the CMAQ results in the hybrid fields.
Yeah, I'm less uncomfortable with estimates of deposition that are based on local concentrations. I'm less uncomfortable with that than I am with concentrations that are modeled. And as I was saying, the 6, 12, and 13 figures give me a lot of confidence, and confidence as a kind of a basis for going forward. And I don't have a warm feeling for, say, 623 and 24 as to the provenance, if you wish, of the points that are plotted there. But I think what I'm inferring is that the CMAQ, which is a chemical transport model, is contributing a lot to those numbers.
I don't want to overstate that. I think you should have confidence in the TDEP data in those other figures. I just wanted to make maybe a minor point that there's a subset of sites in 13 and 14 that it's sort of a nuance of the TDEP data sets. I don't want to imply that you should not have confidence in the TDEP estimates elsewhere. I think where your larger point is, going back to some of the comments yesterday, is maybe a little less confidence in, maybe confidence isn't the right word, but more questions about how the EAQM data were derived, some of the assumptions that were made in the high split modeling, that whole arena of questions. The TDEP data itself, I think, is fairly well evaluated, and using a lot of leave one out type evaluations is shown to be pretty robust.
Okay, thank you for that clarification.
And if I could just add one more clarification, just so we're all clear and all on the same page, we have no measurements of total deposition here. Like when we say when you see something saying deposition, it is not a total measurement. So it is a fusion between measurements and models. So as far as, I don't know of any national network of total deposition measurements.
Okay, I'm looking at the captions of 23 and 24. And the word that jumps out at me is the word estimated. And it's really trying to get a sense of the confidence in those estimates that prompted my questioning.
Could I just make one more point to recognize the distinction between the 612, 613 and the 626, for example? They're all TDEP estimates. We may not have used the word estimate every time it was a TDEP concentration or loading value, but they are all estimates. And that's an oversight on our part for not consistently utilizing terminology to point that out. As Pat recognizes, it's an often used, well vetted sort of estimate, but it is, as Karen said, nonetheless, an estimate. We do not have a measurement for that entity. But a distinction between 612, 613, and 626 is that in chapter 6, we talked about there being two different approaches that we used to consider relationships of deposition and concentration. And the 612-13 is talking about what is that relationship at the same site and when that site is remote from major sources. That's what that is. The 626 scenario is what is the relationship between the concentration at the regulatory monitors, which largely are often near the large sources, and the deposition downwind in the other locations. So they're getting at two different concepts. Hopefully that's useful.
Thank you. That clarification is helpful. And then, but then it's really the measurement at the upwind, the x-axis represents in some way a measurement at an upwind location, and the y-axis is really a model-based deposition at a downwind site. Is that
in
fair enough?
In 626, yes.
Yeah. Okay. So it's that number that I take with much more grain of salt. I tend to be uneasy about those kinds of numbers, and I think we talked about it yesterday at 625 and just sort of the remarkable linearity there, but let's not go into that one. Okay, thanks for the explanation.
Thank you. Judy, you have a new clarifying question or comment? I'm looking at the time, it's almost 10. I thought maybe what we would do is take a 15-minute break and then we will start up with the assigned panelists for section 7. Does that sound good? Okay, we'll do that. So the break timer is over. All right, so we'll get back together, and I'm not aware of anything we need to touch base on after the break. I think we're ready to turn it over to Alexandra.
Good morning. I want to say thank you to EPA for doing extra work way above and beyond what you've already done, and I really appreciate it, and it was super helpful for me, so thank you for that. I'm going to go over some of my comments, and I'll probably include some snippets from Judy's comments as well, and from some of the other center group, including Rich and Kathy, but I'll also turn to them to elaborate on their comments. So chapter 7 is, in my mind, the most intriguing chapter of the document, of course, because it's where we see the application, and it offers various options for consideration to better control for nitrogen and sulfur and deposition-related effects. Now, based on the analyses presented, the conclusion that the existing SO2 standard provides protection against the direct effects of SOx appears sound to me. And I also agree that a new standard to control for sulfur deposition is supported by the body of evidence reviewed in the assessment. Now, both chapters 6 and 7 underscore the finding that SO2 and sulfur, the relationship between SO2 and sulfur is stronger when a standard with a longer averaging time is used. And I agree with this assessment and with the idea of using that longer averaging time. Now, in considering the different standards that were proposed, I see that we have to address deposition-related effects for sulfur. There's a proposal on the table to lower that to 10 to 20 parts per billion for a three-year annual average. And some of the evidence to support this is based on the high split modeling analysis that we were discussing yesterday. And so I just kind of want to leave that out there because I think that was something that we were discussing and thinking about that. In terms of nitrogen deposition related effects, one of the proposed revisions was to reduce the standard from 53 ppb to as low as 40 ppb. And Judy had an excellent snippet from the document showing in chapter 2 that the annual mean NO2 design values that are shown in figure 221 ranged for about 23 ppb in 1980 to about 8 in 2021. And that for the primary and secondary NO2 single year design values, these show that most of the sites are below 30 ppb. And I agree with Judy that if we were going to use this proposed provision, that for this to be meaningful, the level could be lowered to be in line with the evidence that's documented in the report. Now, one of the findings that we've been discussing early this morning, and I think is very interesting, our discussion so far, is that the PM 2.5 annual average is strongly correlated or could be used to control for both N and S deposition. I do agree with EPA that with contributions of other PM components to total mass, changes in composition across space and time with changing emissions due to dust and fire could potentially affect the usefulness of such a metric. But I think we've had some really interesting discussions, and I would like to hear us continue those discussions about thinking about using the annual average PM 2.5, as well as what Judy mentioned, the 24-hour PM 2.5 standard as ways to control for both S and N deposition. And I believe that several people in the group had further comments on PM indicators, and I will let them elaborate on those. In terms of additional areas for research, I just wanted to highlight something that I didn't see a lot of because it's an area that's area of research that's growing currently, which is understanding the ecological effects of particulate matter deposition, total mass on vegetation. So there's a growing body of literature that shows that there are various effects that have been documented since 2017, the end of the last review, on vegetation, including decreased drought tolerance in seedlings, decreased plant growth. There's now research on the effects of elemental carbon deposition, on stomatal occlusion, the concentration of photosynthetic pigments, and so forth. And so I just wanted to highlight that as an interesting area of future research. And I think understanding those ecological effects of particulate matter deposition to vegetation and soils is especially relevant and timely in the current context of increasing wildfire and dust emissions in the central and eastern, and now really across the entire United States, as we're saying with the fires. So with that, I'm going to pass the mic to my colleagues.
All right, Judy's next on the list.
Yeah, so yeah, I do agree that looks like the longer averaging time better represent deposition related effects on ecosystem. However, I felt the relationship and between the proposed concentration range and the ecosystem effect need a better documentation. And I have a difficulty to find the rationale for the 200 and 400 ppb range for the so-called second highest daily 3-hour maximum SO2. Did I get that right? So that if you look at figure 2-23 on page 2-27, it shows all sites of SO2 secondary standard design value less than 500 ppb, with 78% of the sites have concentration less than 25 ppb. And only 4 sites, so that's 1.1% of the design value is between 201 and 500 ppb, which is a very large range, but there's only 4 sites fell above the 200 ppb range. And the preliminary conclusions say that 95% of the maximum 3-hour average concentration have been less than 200 ppb, and 99% is less than below the 300 ppb. I felt that 240, 400 ppb seemed to be a wide range, and it's kind of on the high side. Maybe a 200 ppb or 200 to 300 ppb will be justifiable for 3-hour average secondary SO2 max. And that with respect to the 10 to 22 ppb SO2 value for the 3-year annual average, that seems like it's being associated with different places in chapter 6. That was the SO2 concentration range was during the 2018 to 2020 to the median sulfur deposition ecosystem 3 area with probably seems like around 5 kilogram per hectare year of deposition. This value seem to be high if you compare with the annual SO2 standard that demonstrated in figure 2-25. That's so the annual average has been less than 5 ppb since 2001, less than 1 ppb since in the recent year. That's kind of much lower than the 10 to 20 ppb that proposed here. Thanks for Alexander regarding the NO2 that 30 ppb and below seem to be more justifiable than the proposed 40 ppb. Chapter 6 noted that the recent median nitrogen deposition in the range of about 10 kilogram per hectare year in ecoregion 3, also less than 30 ppb in terms of 3-year average of NO2. And figure 620 shows the relationship with between the nitrogen deposition and average NO2 concentration with the x-axis now exceeding 20 ppb. Scale to 25 ppb. So your rationale for 40 ppb doesn't seem to be consistent with all this measurement. And I like to see table 7.1 maybe would be more informative to relate the proposed secondary NAAQS levels to those median or nitrogen and sulfur deposition value in terms of maybe kilogram per hectare year, and then their relationship with ANC, the target value, and critical load. I don't really, seems like can separate the acidification and the terrestrial ecosystem. I think a bit more informative, we can have a better sense what those level with what deposition level with what NAC target value with what critical load, if it's all possible, that will give us a better view of or better understanding of their association. It's just this chapter doesn't. I read back and forth as I went back to different chapters. It seemed to be loosely, not really tightly connected. With respect to the second question, area for future research, I feel one key factor is kind of interesting. Stephen mentioned is more comfortable with measurements. We're measurement people, not modeler. So it's needed for adequate model input. And then we like to really have a corresponding measurement network for model evaluation. Different networks, EPA point out summarize lots of different networks. And different networks established at various times and managed, operated and funded by different federal state agencies with many, not all of them, non-co-located measurement locations. So they have different sampling duration frequency, different data format, different data so to acquire. I just want to give you some examples. Sampling location, yes, urban, suburban, rural, remote area. Sampling method, we have continuous 1 minute average versus the integrated filter pack is 24 hours versus active, that means with a pump, CASAC sampling for weekly. And we have a passive sampling, that's no pumps. So it's an ammonia network, that's 2 weeks integrated. So it's all different time period we're talking about. And with different sampling method and sampling duration. And with improve every third day with CASAC, with CSN every 6 days. I can go on and on. Every one is different. So, and with respect to the frequency and duration, and I would encourage EPA at the time they kept want to kill this site and they shut down that site, so that maybe consider synchronized to the extent possible. So we can achieve the best benefit. They have some co-located measurement with the similar time period. I know it's difficult because every network is operated by different contractor. And so we can actually acquire concurrent total sulfur, that means so SO2 plus sulfate and total nitrogen, NO2 and NO3 and NH3 and NH4. So that I also like to see some research conduct to compare measurement model estimate dry deposition velocity. I was so surprised that I listened to what Charlie said. He thought that the deposition is pretty good, but I'd like to see some more model estimate dry deposition velocity, because you're not using the measurement dry deposition velocity to be done. And that areas with respect to the section 7223 relating deposition related effects to air quality matrix, noted that oxidized nitrogen deposition in rural areas mostly from nitric acid and particularly nitrate and rather than NO2 with higher ammonia emission as suggested inorganic ammonium contributions. Better relationship I've found between the annual average PM2.5 nitrogen deposition as compared to NO2 versus nitrogen deposition further emphasize the importance of the set of the correct annual average. We did quite a bit of this equilibrium model in the past, but there hasn't seen much of the publication. As nitrate formation I mentioned yesterday associated with nitric acid ammonia, or nitric acid formation depends on the NAAQS and the VOC, similar to that ozone formation. So I would like to see additional research assess limiting precursors for nitric acid and particular nitrate formation and the current emission and different emission and meteorological condition for the sensitive ecosystem. And that to better understand that, those equilibrium model will give you a sense of that the different response of PMS and nitrate concentration to changes in sulfate, nitric acid, that ammonia concentration and different geological regions. So this is important. I felt that the effective of nitrate reduction may depend upon interrelated ammonia and the NOx reduction. I think it's a really important concept and deserves more attention. Thank you.
Thank you.
I'm sorry, can I just answer one of her?
Go ahead. Yeah, Karen.
Thank you so much, Dr. Chow. Those comments were really interesting and very helpful. I do appreciate it. And I wanna point out or maybe just explain something that might be helpful. I know you mentioned, Will, I'm looking at these figures and I don't really understand how you're arriving upon these numbers. And so maybe just to look really quickly at like SO2. So there's two figures, for example, with the I'm looking at the 617 and 618. So this is the annual average one. And so if you're looking to say like, well, I wonder what monitors and design values are associated with this median deposition value, then the place to look would be figure 618. Because that figure is going to say, okay, like we are plotting what the highest monitor is contributing to that area and versus the median deposition for that area. So when we said, oh well, when we look at this information and we look at median deposition at that's maintaining 5 or below. What we see in this plot says that there are a few monitors as high as 22, but generally speaking, almost all the monitors are below 10. That's where that's coming from. And then the one above
Actually
it,
below 5 for 618.
yeah, and many even lower. And of course, with SO2, as we know, there's a lot of variability across the SO2 monitors, right? So it's more variable than some of the other pollutants. So thanks.
Yeah, thank you. But the point is that 10 to 20 ppb is 21 ppb is really relevant for the most recent year. And they're not really that it seems to be high even with most recent year. That's why if you look at this, you get a few 1-2 points at the 21 ppb, but mostly it's less than 5 ppb. If you compare with the measured value, they're much lower than your 10-20 ppb values.
Okay, are we ready to move to Rich?
So I agree with and fully support everything that Alexandra and Judy said. So I should probably just be quiet, but no. I'd like to start out talking a little bit about the concept of uncertainty. And I understand that you have a responsibility to set these secondary standards at levels that are neither more stringent or less stringent than necessary. I did a word count on uncertain in the document and identified 400 times where I kept feeling like I'm getting a slap in the face every time I saw it, because very typically uncertainties are evoked to justify not setting the standard more stringently than needed. And there's another side to that that I think we should consider as well. I remember there was a lead NAAQS review maybe 3 cycles ago, and there was an eco guy there, and one of the health people asked him, well, aren't there any plants or animals or fungi species that are more sensitive to lead than humans are? And he said, well, I don't know, what are there, 2 million species other than humans out there? Do the math. You know, of course there are. Of course there are. And you know, we made such incredible progress with lead. It's even maybe a bigger success story than sulfur and oxidized nitrogen here. And yet the current levels of lead in the environment are still many times higher than what life evolved under. And the same thing is true for sulfur and nitrogen. Charlie had, I thought, this great idea yesterday of what if we made some serious calculations of natural baseline conditions here and considered the extent to which the chemical environment that we're exposing these, I don't know if there's millions, I don't know how many, I don't think they know, but plants and animals too is much different than what they evolved under, or at least in recent years, much different from that. So, you know, a prudent approach might be to consider that, you know, of course there are likely to be effects at levels below that we currently understand. I looked up the ISA last night because I wanted to confirm something, and turns out that compared to the previous ISA, there were no causal relationships anywhere that had been previously identified that had disappeared over the course of time between the 2 ISAs. And in fact, there were 3 new causal relationships that had been identified over the time period between the last ISA and the current one. So even though the concentrations of sulfur and nitrogen have further declined, oxidized nitrogen have further declined, more effects are being identified. And I thought I heard maybe 4 or 5 other kind of new concepts introduced yesterday by Bill and Hans and Bob and others that we keep, the longer time goes on, the more we find that there are effects that we didn't know about. So I guess a prudent principle, might be to this idea, I think, of taking the current annual NO2 and sliding it down to near the level or maybe slightly below where the data lie, and the annual SO2 and sliding that down to near or slightly below where the data currently lie, I think actually serves this uncertainty concept in both directions. We're not, if we don't go way below the current levels for those two pollutants, we're not unnecessarily setting the standard more stringently than necessary. We're not unnecessarily burdening polluters, and we're also taking into consideration that we understand that there are effects at levels below the standard. So I just wanted to, toss out that perspective as a way of looking at it. At the end. Oh, I'm missing a page of my notes somewhere. Sorry. Well, from memory, then, I guess I'm supportive of those two concepts, as Alexandra and Judy were. I think if we don't go after PM in some way, there's no other way to get at ammonia. That's just it, So if we want to do something about reduced nitrogen, which seems really to be kind of the most important problem here, then we've got to use some sort of a PM-related indicator. I think, as Judy pointed out, going down to 12 doesn't do anything. It's not going to change ammonium anywhere because that's already the level of the primary standard. So we could do that. We could feel a little better about remedying the I think poor decision to set it at 15 the last time, but we're not going to do anything. And furthermore, it seems like it's justified to lower it below the level of the current primary standard, which itself is under recommendations for lower levels. So I think Judy's suggestion of 8 to 10 is really fully justified. I liked as well her point about the 24-hour secondary PM 2.5 standard, lowering out to 25, would provide additional protection in certain areas. They're comparing the 24 and annual average, there are certain areas that are much more severe relative to one compared to the other, and that would capture a lot of additional areas where the annual average might not do the trick, and would absolutely be very beneficial in terms of visibility protection, and far more appropriate than the current one. I personally also really like consideration of PM species as a possible indicator. I think as we move towards the future, PM mass becomes a less relevant indicator for SNN than do the SNN species that we measure. So there are all kinds of variations of those. I think you've identified them. I know you've raised the issue of problems with the new reference method, and that's always problematic, but I did want to point out that those methods are used as the basis of the Regional Haze regulatory program and have been used for years in that way, that the very similar methods that are applied in the chemical, what do you call it now? Chemical speciation network, which are very, very much harmonized with the improved measurements. There's all kinds of co-located sites and intercomparisons and constant working with people like Judy and others and EPA to make sure those measurements are consistent with each other. A number of graphics and information that you've presented here are actually based on the combined CSN and improved data taken together, because we're talking, especially with the SNN species of regionally broad scale pollutants, they really don't differ that much from each other, with the exception of, severe mountain valley areas or something like that. But the data are certainly comparable with each other. And then the last point I wanted to make about that was that in the 2012 PM NAAQS review, the agency was recommending the use of those speciated data from the CSN network to as the basis of a reconstructed light extinction measurement, which I tried to push the other day. That's another indicator that I think would actually work really well. So anyway, I think that's the end of what I had to say. In terms of research needs for getting it all out here, a couple of additional ones I thought of were maybe continued research into application of remote sensing techniques to quantify total column SO2, NO2, ammonia, PM 2.5, and carbonaceous aerosols. It's a little silly to think that, some of these things, that it's really the total column concentration that we ought to be concerned with. And then to say, oh, we can measure it, but you measure it 3 feet off the ground, we're missing an awful lot. Donna was telling me in some places they've made ammonia measurements illegal. So maybe that's the only way we can do that then. But anyways, not only the continued research into the application of those remote sensing techniques, but to compare those and merge those data with surface observations and air quality models, I think would be useful. Continued development of methods to quantify gaseous and particulate, sulfur, nitrogen, and other PM species, especially as they might be applied to large existing monitoring networks. We've certainly seen problems in the past when we try to come up with a good idea for a NAAQS, but then we go, oh, we don't have a way to measure. And then I mentioned this the other day, but I think additional analyses into the chemical and biological changes that have occurred in these sensitive aquatic and terrestrial ecosystems over time. I think Charlie advocated the same thing. We've done this fabulous experiment. Let's see what the nature of recovery or non-recovery or hysteresis is, and how does that relate to other emerging issues like climate change and historical legacy and so forth. So I guess that's all I had to say.
All right, thank you. Next up is Kathleen Weathers.
Great, thank you. And I'd like to add my thanks to EPA as well for the presentation this morning. It was very, very helpful. I'm in agreement with my other 3 colleagues, in complete agreement. And so I'll step back a little and give a couple of overarching kind of value-added comments, kind of big picture comments. I think in response to the question about the discussion and key conclusions based on the last 2 days of conversation, there are some things that need to be added. And the first one I would say is following Charlie's and my and a number of other people's argument for deposition standards. It seems like this was one place where we might play out that articulation of the wisdom of having deposition standards. Not that I think that they will be adopted at this point, but it's another place to lay out the wisdom of that. And so, Charlie, I'd be happy to be involved with the writing of that. And then in terms of the standards put forth, I agree with my colleagues about the revision of the SO2 standard to a cumulative annual 3 years. And I think that the evidence that's presented is supportive of that. In regard to the other standards, it seems to me that, with Davin's and Judy's explanations, as well as with Bob's comment about protection of aquatic systems, freshwater aquatic systems and nitrogen deposition, that the lower limit should be rejustified. It's following along with what Rich and Judy have just laid out. And then I think that it would be worth working backwards from nitrogen deposition to watersheds, to catchments, as Bob pointed out, to think about what the actual standards are for nitrogen deposition, PM and NO2, that provide protection. So working backwards from those numbers that Bob was talking about, saying that, is 6 kilograms per hectare protective of downstream aquatic systems or not, and then reconsidering the lower standard for both NO2 and PM 2.5. So I would appreciate the discussion and the reconsideration of those two standards and the lower limits of those two standards be included in the next version. So those are kind of big picture comments, and again, I am fully supportive of the details that Alexandra and Judy and Rich.
Thank you. Maybe partly because I am not the experts in secondary that the rest of you are. I heard a lot of support for lowering, but I don't have a lot of clarity about our recommendation. So I don't know if there's anybody who feels like we're ready to actually put some solid numbers down. I mean, I heard a bunch of numbers in different ways and different ways of thinking. Maybe it's just me getting a little bit lost. But I think, there's two ways we could approach this. We could say things should be lower, EPA go away, give us another draft and give us your justification. Or we could say, here's what we think. And maybe we ought to have a discussion about that first, about which direction. I mean, EPA is under a court order, but we are the scientific advisors. So I think my understanding is we don't need to factor that into our advice. Is that a fair comment? I'm asking EPA.
Yes, I think that's a fair comment. We're looking for comments. It doesn't mean that in the end we won't have to move forward anyway. And so, even if CASAC, for example, does ask for another draft, the more information that you give us, so that if we have to move forward, we have the information to move forward, would be the best. Yeah, I think that's the best guarantee I can give.
Okay, so what I'm hearing then is regardless of whether we want to send EPA back to the drawing board to give better justification for some of the ranges, it would be helpful for us to give pretty specific advice. Is that a fair articulation of what you just said?
Yeah, that's correct. Especially it's really important, as I think you've all done in your discussion, is backing it up with the rationale. Like, we think this because of that. Okay.
Yeah, and how do we move forward here to actually come up with some specific numbers? Do we want to try to do that today? Do we want to take a break for people to chat and come up with some draft table, or just keep talking? Alexandra, were you going to say something?
Well, I like your suggestion of taking a break, and I really liked Kathy's suggestion of backing up the numbers. So the groups that were focused on aquatic and terrestrial ecosystems, thinking about those ranges of values that we're targeting, and then just coming up with the numbers based on that. So it seems like that could be a good break to discuss that and take that approach. And if I could just ask at a quick clarifying, when you go about that process, if you're looking at some of the information in the tables, keep in mind that the relationships that are provided with respect to the standard levels are median depositions, right? So we know that there's a variability across an ecoregion, and we were trying to provide what is a relationship between that deposition and a standard. So when you look and so in the, for example, in the slides that I provided at the beginning, we tried to provide those types of numbers based on that type of concept, with those values being median values, in case that's helpful.
So I think maybe Rich is going to help me figure this out. Charlie first.
Thank you. So I would second your suggestion. I think, we have a group here, we're thinking about it, everything is fresh. And so if we could brainstorm a little bit and come up with ideas for numbers and justification, it would be time well spent. I think that would be very effective. So.
Okay, Rich?
So the other part of your original question that I was thinking about was, sending EPA back for more work, which I think we should maybe also consider doing, in addition to trying to come up with some specific numbers ourselves. I think there's good justification, especially in terms of the long time delay between the ISA and the current and all of the new relevant research we've heard about, that we could send them back in that area with kind of a focused set of recommendations there. And what was the other? Oh, and then the other one was the absence of the sort of classic risk and exposure assessment, trying to compress that in. It's another thing where there kind of really wasn't enough time, and we might at least comment on that for the future, because we have a lot of concerns about some of the issues there that need clarification. So I think we could, in addition to trying to come up with some recommended numbers, give them some fairly focused.
Okay, so what I'm hearing is, well, Donna, do you want to weigh in before I summarize what I think I heard?
I had a question for you.
Okay.
So go ahead.
So what I'm hearing is that we should break for a while and into small subgroups. We have to do it, less than half of us, and I'll defer to you all to self-divide, and we can figure out how to incorporate people on Zoom also to do that, to have those conversations. And there's two parts to the conversation that I'm hearing. One is coming up with recommended numbers, and the second is very focused recommendations for how to update the document. And with that is, do we need to see another draft or not? I think that should be part of it. That should be part of our discussion as well. And whether that will happen or not, given the court order, I guess is not our problem. Donna.
Yeah, this is a question for EPA. If you could just clarify what the implications of non-attainment of a secondary standard are for states. I mean, I have a good sense, I know what happens when you don't meet the primary standard, but we haven't been in that situation of not meeting a secondary standard.
Okay, so I obviously am not working on that side of the house anymore. I started out my career on that side, but and David can certainly add if I say anything incorrect. But my understanding is that the process for designations for the secondary standard would look like the primary standard. One would have to go about designating and determining what areas are contributing, right, that would be included in the areas of non-attainment, and then there would be a process for establishing, the state implementation plans, et cetera. I think my understanding is the timeline is not laid out as firmly as it is for the primary standards, but a timeline would need to be put in place nonetheless.
Thank you. Charlie, you had a comment?
Yeah, more towards procedure. So there are a couple of things I just want to make sure don't slip through the cracks. So, one is there are some things that we talked about that's not clear what section they would go in. So we talked about deposition that I think's been addressed, but there's also uncertainty, and it's not really clear if we addressed some comments on uncertainty where they would go and who would do that, and a few other things. So just to make sure that those are covered. And then the second is Aaron sent around a report that had sort of an idea about sort of the length and detail that had been used in past reports. So we can use that as sort of a guide in terms of the scope of what we would write up. But are you going to also go over timetable, when we need to do what by when, so we can move everything along?
Yeah, well, we typically do a brief summary of that kind of stuff more towards the end of the meeting, and I'm seeing these small group conversations as more of a brainstorming preliminary set of recommendations that we hash out that we then vet in public today. With respect to your questions about the report, like where things go, I don't think we need to decide that in advance. I think if we get drafts, Aaron and I will figure out how to put it together so it's a coherent report, whether we fold it in. If you have a recommendation while you're writing it, certainly you should share that. But there's no problem with us having sections that are not in direct response to the charge questions. We could just add sections to our report as we need to. So, and as far as length, if it needs to be long, it should be long, but it doesn't have to be long. A couple paragraphs sometimes is plenty. I mean, sometimes only one paragraph is plenty. Sometimes you need several pages. So whatever you need for your consensus comments is what should be written, and it's okay to be long or short. The letter will, by its very nature, be much shorter than the consensus comments. But that will be a distilled version of the consensus comments. And then, of course, your individual comments, you don't need to delete anything. You'll want to finalize them. So if you end up, copying from individual comments into the consensus comments, there's no reason to delete that. You can just keep that. And you can elaborate more however you want. So there's no external editing of the individual comments. Or probably no, maybe Aaron does something, but I don't see that part. Yeah, but the important thing I think today is that we come up with a recommended set of ranges, and we've heard a bunch of discussion. I think we're ready for just breaking into small groups. Do you need any more guidance from me? I feel like you all are more expert than I am, so if I just leave you to your own however you want to separate. Go ahead, Hans.
Yeah, I just had a question with regard to interacting with the Zoom folks. We're going to have several groups, I guess. So how do we deal with that?
Yeah, Aaron, do you have any advice on that?
No, I'm not clear how you're going to divide right now either. So maybe can you guys propose how many groups you need and who goes in which, and then maybe we'll ensure that it's less than half of the panel for each group, and then the Zoom folks can indicate which group they want to go with. Then I guess maybe whichever group there is, if someone has a Zoom login, you can start a meeting there and share it with the ones on Zoom. But I think preliminarily we need to figure out how many groups there are, what groups, how are you going to divide those groups, and who's going to join each group.
Yeah, and my preliminary recommendation is at least the Chapter 7 group should be a group, and maybe there's a few people that want to self-select into that group. And then there sounds like there's an aquatic group, and I'm not sure what else there is. Kathleen?
Based on basically what you said, so that there's a group that's considering the PM 2.5 and NO2 standards, following along what Judy and Davin had said. And then there's aquatic group, which is considering new information in many ways. So it seems like those are two slightly different things. We've heard some very solid recommendations based on the data and the analyses that have been presented for both the lower end of PM 2.5 and NO2, but the aquatic piece is new. So I would suggest those be separate.
So two groups, does everybody feel like they know what group they might be in? Is that correct? So who would you raise your hand if you're in the aquatic group, just so I know? That's Bill and Hans and Charlie, and there's somebody online, Bob and Doug. Okay. And then would you raise your hand if you're in the Chapter 7 group? That's Judy and Alex and Rich and Donna and Kathleen and Davin and Ivan. And there's a few of us that haven't self-selected, but it's okay. Go ahead, Lori.
Just for logistics, I offered yesterday to start a overarching draft on the uncertainty comments, and I propose that I put myself in that group right now and work on that, and then we could share it around.
Great. So we'll have a third group, which is an uncertainty group, which is you right now, and anybody who's going to join you. Anybody want to join her that's not already in a group? I'm sure there's people that want to contribute that are already signed up, but you can work on your own too. Okay, so it sounds like we need to figure out two Zoom links. Oh, Stephen.
Is it voluntary for uncertainty?
Stephen, we see your hand up. We're not sure what your why.
Uncertainty group.
Okay, thank you. All right, so Stephen and Lorraine will work together on that. And it's 11. Do we try to touch base before lunch? Yes, so 11:45. Is that 45 minutes? Is that enough time? Okay, well, we'll break and take a pause on the YouTube and have separate meetings.
So will links be sent to us?
Yeah, we'll work that out.
Okay, great.
Anybody who's in a small group, if you have a Zoom, you just want to go ahead and send to the people that are on Zoom. You can just do it privately. There's no need to have it managed, but I think if you need help, it sounds like we can get help.
You remember who was on Chapter 7?
So just to clarify, for the aquatic group, someone will send out a link via email?
Yeah, somebody's going to figure it out for the aquatic group. So we'll follow up.
Thank you.
So we're supposed to get back together, and so I'll let people assemble. Wait. Oh. So we'll get back together, and we'll hear from the aquatic group, and then we'll take a break for lunch, and then we'll revisit the Chapter 7 group. I think they should switch back to the meeting Zoom, and then right, everybody should switch back to the meeting Zoom. So we're just waiting a minute for the panelists that were in a different meeting to come back to our regular meeting. And then Chapter 7 people will probably need to continue their conversation. Maybe we'll take a little longer lunch break. Maybe you all can advise me how long you need with lunch before we break. So, are they back yet?
Right. Was Ivan still on with you guys? He was? Oh, okay.
There's still one or two people from the standards group that are waiting to join Zoom. Do you want to email them?
Yeah.
I'll go ahead and get started. So our plan is to touch base with the aquatic group, the uncertainty group. And do you have anything you want to share now or not? You know,
it ended up just me. Somehow I didn't connect with. So I just sent to everyone who made comments on uncertainty what I wrote down, and to try to begin to capture.
Okay, so. And we don't necessarily need to deliberate further on that unless you think we do.
I don't think so,
because we already had quite a bit of discussion on the topic. So if you're just summarizing it, that's fine.
I don't think there's anything that wasn't said.
Okay. Yeah. All right. So nothing more on uncertainty, but we'll move to the aquatic group, and I guess Charlie's going to take the lead on sharing your perspectives. Is that right?
Yeah, that's correct. So the aquatic group met. So it was Hans, Bob, Bill, Doug, and me. And what we came up with is that everybody in the group, except for me, has some detailed information on total maximum daily load analysis for estuarine systems. And those all include an atmospheric component. So what we're going to come up with is we're going to come up with the current loading. We've got a table that indicates all the details of the TMDL, and we're going to compare the current loadings to the bay and the atmospheric component, and with the projected management actions that are needed. So you'll get the ambient values and then the projected values, and the values for the atmospheric component will be prorated in there. And so then the write-up that we have for Chapter 4 and 5 for coastal systems will include that as part of the analysis, and then we'll be able to hand that off to the chapter 7 group if they want a synthesized version of that, but it will be in a deposition loading, so it'll be in kilograms per nitrogen per hectare per year. And then anyway, so that was the plan. That was the plan of attack. So does anybody have is that okay for a summary? Anybody else have anything to add?
Is there anything that, maybe it sounds like this is work in progress. Is there anything that will allow us in public to deliberate what lower standard is appropriate based on what you've discussed so far? It sounds like you need to finalize a lot of this, so that will take some time offline.
It's going to take at least a couple of days offline, I think. Yeah. It's doable, and we have assignments to do it, but I think it's beyond what we could do today.
And will this have implications for how we deliberate today? Because it sounded to me like what you all are thinking would potentially lower the recommended levels quite a bit.
I don't know. I mean, we talked about a target of about 10 based on recent studies, and I think that's consistent with what we were talking about earlier today. The thing that I like about this is that the group, there was some concern that there was a lack of connections, certainly quantitative connections with coastal systems. So I think EPA will be able to take what we've done. It will be from agreed TMDL analysis for Mississippi River, Chesapeake Bay, Wacoit Bay, Tampa Bay, what am I forgetting? Neuse River. So a number of sites that are small, large, and sort of diverse settings. So it'll be a pretty good summary that they can pull on and translate it directly to an atmospheric relevant, what the current value is and what the proposed value is in the TMDL agreement. So it seems to me it will be a good piece of information that could be brought to bear in terms of justification for levels of deposition that would help mitigate against ecological effects. And we also talked about, there have been some recent studies talking about improvements in submerged aquatic vegetation for sites that have implemented reductions in nitrogen loading. So that would be a good way of sort of indicating the biological response in terms of habitat improvements. So we're going to try to add that in as well.
Okay, does this leave the chapter 7 group in any kind of limbo that is challenging for the deliberation? We will have a chance to deliberate in public again. So given we don't have these numbers and we're not going to get them today, then yeah, maybe that's just where we are. Okay. Then I know chapter 7 needed more time. So we're about at lunch break time, and maybe some of us get more than an hour for lunch break, and chapter 7 can tell us when you want us to come back together. Like, how much more time do you think you need with lunch? But I'm not asking you to work through lunch.
I'm thinking about 20 minutes to finish up our discussion, maybe 10 just to draft the comments, maximum 30 extra minutes.
So we'll take an hour and a half lunch break then and come back at 1:30. Is that agreed upon? I know there's some people that need to leave as early as 3. Anybody need to leave earlier than that? Okay, so another break for an hour and a half, and we'll see everybody back at 1:30.
Just a quick question. Alexandra, then will we meet on the same Zoom where we were before in 1 hour?
Yes, let's do that.
Okay, great.
So we're trying to get assembled so we can get started. It looks like we're mostly together here from our break. So there's a couple of things that I want to make sure we do. One is we got an email from, who is it? Dr. Howarth, and so we'll start with that, where he's going to present a slide with an analysis. And then I also, we had a little bit of a side conversation about thinking about a different indicator, so I'll make sure we cover that, and I'll defer to this chapter 7 group, whether you want to discuss before or after that. So, but first we'll go over this. So go ahead, Bob, and share with us your analysis.
Yes, thank you. This is building on the work of the aquatic subgroup from this morning that Charlie briefly presented just before lunch. And what we said we would do is look at a bunch of impaired coastal water bodies, estuaries, which have required TMDLs that have been approved by the EPA, and then determine how atmospheric deposition interacts with those. So I had said at the time that it would probably take a while to do it, and it will for the most part, but I did one of them over our lunch break, which I just want to very quickly show you here. The case is for Quake Bay. It's Cape Cod, Massachusetts. TMDL was approved 3 years ago. You can see from the cover there on the side, it's a pretty heavily developed watershed. It's also a state park. It's a National Estuarine Research Reserve, and it's a National Science Foundation research site. I won't go through the math. It's all right out of the TMDL, but it's consistent with peer-reviewed literature behind it as well. The take-home message is that if we treat atmospheric deposition as equivalent to other sources and look for the same decrease in atmospheric depositional inputs as we require from other sources under this TMDL, then the current deposition, which is 13.1 kilograms nitrogen per hectare per year, has to go down to 8.3 kilograms N per year. So again, we'll do this for Chesapeake Bay and the hypoxic zone, the northern Gulf of Mexico, and the Neuse River, and other systems as well. But I wanted to show you what this would look like. And here is one number that says that if we want to start being protective for this system anyway, then the target should be to take the deposition down to well below 10 kilograms per hectare, which is what we've been talking about earlier. 8.3 is the number from this one. So thank you.
Thank you. Are there any clarifying questions or comments from anyone? I guess probably just because this is outside my area of expertise, somebody could reiterate how we are going to then translate that into something in the air. That's part of what, is that part of what the standards group is doing?
I think that would fall into the standards group. I mean, I tend to agree with the viewpoint of Charlie and others that having a depositional based standard makes sense. But if we don't have it, then you'd have to translate that 8.3 kilograms to something else. If you use the figure 6.25 that we've been discussing before, that turns out to be a value of 8.3 micrograms particulate matter per cubic meter.
Thank you. Hans and Bill, you wanted to follow up?
Yeah, I just, great job on that, Bob. I just wanted to stress that we're talking, us aqueous people, we talk total N. And that's one thing to keep in mind. And you can see it right there in Bob's calculations. So just wanted to point that out. We're not only we're not only concerned about NOx, but reduced forms of nitrogen, including organic nitrogen. And in many of the estuaries that we're concerned with, organic nitrogen is probably in the long haul biologically available. So just wanted to point that out.
So I think this is an opportunity to bring up the question, what about us recommending total nitrogen as the indicator? Why or why not? Why, I think we just heard. Why not? Rich, did you want to say something?
I wasn't going to say why not. I was going to say we should be maybe a little bit more specific if we can about how would that be measured.
Do you want to elaborate on why? Or maybe, again, my lack of expertise, that's not obvious to me. Why we have to pay attention to how it's measured.
Well, because unless we can have a deposition standard based on measured deposition, or measured wet deposition even really, or measured estimated wet and dry deposition, unless we can have that, then we need to base it on something that we can and do measure in the ambient air, according to what our EPA people keep telling us. So I don't want to get ahead of the Group 7 recommendations, but we talked about the advantages of using a fine particulate matter total N metric. That would include N from nitrate, N from ammonium associated with the nitrate, and N from ammonium associated with the sulfate. So we like that as the best indicator. It's imperfect, but it's something that's routinely measured at a lot of sites. And there's no need for development of whole new methodologies and so forth. So.
All right, thank you. Bill and Doug both have their hands up, and then Bob. So Bill, then Doug, then Bob.
Yeah, following on directly from Rich's comment, there's a real opportunity with the current system of measuring PM 2.5 elemental carbon and black carbon. Well, why not just turn on the other side of the carbon analyzer and measure a total nitrogen in the particulate organic matter as well? So it's not a technically challenging leap, or wouldn't require new sampling approaches. So that right now there is a whole component of total nitrogen deposition, which is what we can measure as the dissolved organic nitrogen fraction in rain, which we've known for a long time is important in surface waters. It can be 20, 30, 40, 60, 70% of total dissolved nitrogen in surface waters. Well, it's typically not measured in rain, and yet it can be 30, 40%. Limited information that's available and published, but it can be easily of wet deposition at least 30%. And it's really intriguing to think that, we have these PM 2.5 that's being sampled, and we can measure the organic N fraction in that along with the carbon that's currently being measured. So.
All right, thank you. Doug, you're next.
Yeah, I was just going to say that the challenge is in the measurements, as I think others are saying. There's no network that really measures organic nitrogen. And then as well, most of the networks miss some of the oxidized species. And then ammonia is another one, which there's now a network through NADP that does that, but EPA is talking about cutting a lot of those sites as soon as next year. So it's a real challenge to have measurement sites where enough of the species are measured to, approach total nitrogen. That's the whole reason TDEP came into being, was to fill in those gaps.
Thank you. Bob.
Yeah, I agree with what Doug and Bill have just said. Let me just add for the for the McCoy Bay case study there, the deposition does include organic nitrogen as well as ammonia. That was done as a research project funded by the National Science Foundation, Kate Lloyd's work, and it's been used in the TMDL. So that's part of the reason the number might look a little high to you. It actually includes all of that. From the standpoint of what happens in these coastal systems, some of that nitrogen's falling right on the water surface. A lot of more of it's falling on the watershed and then being moved downstream to the estuary over time. The available data suggests it doesn't make much difference whether that deposition is coming in as organic nitrogen or oxidized nitrogen or reduced nitrogen. The retention in the landscape, the export downstream, the use in the estuaries is going to be very, very similar. So I think we, in terms of these coastal systems, should be looking at a total nitrogen standard. If the particulate matter is a way to translate that, I think that makes sense. I like the idea of looking particularly at the nitrogen content of the particulate matter, as Bill suggested, as opposed to the total. Thank you.
Thank you. Are we ready to move on to the Chapter 7 report? Oh, Judy, sorry.
Yeah, I'd just like I thought that Bill's comment is very interesting that because when we do acid deposition studies, we do measure both wet and dry deposition with total, we call it CHNSO, carbon, hydrogen, oxygen, sulfur, and nitrogen. So it is feasible, come to think about it, for this chemical speciation network or the improved network to use this filter to measure total nitrogen. We just need a very small punch of it. But the disadvantage, I guess the disadvantage is, I don't know if it's a disadvantage, you can separate species, different species, reduce oxide nitrogen. So, but anyway, this is something probably should be thinking about, probably a pretty easy task, analytically I'm talking about. And with respect to the organic nitrogen depth mentioned, that's will take a little more effort. The same ion chromatographic analysis for nitrate can also that used to quantify the organic nitrogen, but that's just not being done because even with I feel the entire PA does not really address, maybe because of not much data for all the reactive nitrogen or why it is barely mentioned or any oxide nitrogen just not being getting enough attention.
Okay, thank you. Maybe turn it over to Alex for Chapter 7 now.
I'm going to speak up because I realize there's a little bit of noise in the background, but if somebody can't hear, just let me know. So we came up with a variety of comments on the proposed standards. For the annual PM 2.5 standard, we recommend that the secondary annual PM 2.5 standard level be in the range of 8 to 10 micrograms per cubic meter. And our justification for that recommendation is based on the data that's in the document. First, and in remote areas, we see that improved PM 2.5 levels in that range of 8 to 10 for the period 2017 to 2019 showed total S deposition levels below 5 kilograms per hectare per year. We see that on figure 612 with levels generally below 3. And total deposition level, nitrogen deposition levels at or below 10 kilograms per hectare per year, and that can be seen in figure 613. In addition, in the ecoregion analysis, which encompasses, as you noted, the areas near sources, PM 2.5 levels in the range of 8 to 10 are associated with total sulfur deposition levels also below 5 kilograms for the period 2018 to 2020. And we see that in figure 623, and total nitrogen deposition levels less than 10 kilograms per hectare per year for the 2018 to 2020 period, and that's in figure 625. And then lastly, as noted earlier, hotspots of total nitrogen deposition greater than, we're just saying about greater than 15 kilograms per hectare per year in California, the Midwest, and the East correspond with areas where the secondary annual PM 2.5 design values for the most recent period, 2019 to 2021, are in the range of 6 to 12. And that's based on the bins that are shown in that figure on figure 227. We want to note that this range is consistent with that proposed in the PM NAAQS panel to control for other or additional welfare effects. We request that the EPA provide a more quantitative assessment of this data and indicate what additional amount of protection would be achieved at this recommended level of 8 to 10. For the NO2 annual standard, we recommend that the NO2 standard be lowered to less than 20 parts per billion to preclude the possibility of returning to deleterious values, which we can see in figure 219. Our justification is that we can see that at a weighted annual average NO2 average concentration of 20 parts per billion, the total nitrogen deposition remains at less than 12 kilograms per hectare per year, which we can see in figure 620. For the SO2 standard, we recommend a proposed annual SO2 standard of 10 to 15 parts per billion, which we recognize is very similar to that which was proposed by EPA, to preclude the possibility, again, of returning to deleterious values as seen with the emergence of high SO2 concentrations in 2019, 2020, and 2021. And we can see that in figure 225. This level of 10 to 15 mostly maintains sulfur deposition at less than 5 kilograms per hectare per year. And we can see that in figure 618. Lastly, with regards, our second to last, with regards to the 24-hour PM 2.5 standard, we recommend that this be at a level of 25 micrograms per cubic meter. We note that the 20 most visually impaired days in the US are heavily dominated by nitrogen and sulfur. So a revised 24-hour standard would control for episodic deposition events. And we note that this is also consistent with that proposed in the PM NAAQS panel to control for other welfare effects. Lastly, as Rich was saying, we recommend that EPA consider a total N PM 2.5 indicator to achieve a better measure of total N deposition. A PM 2.5 mass indicator may be adequate for now, but may not be adequate in the future due to changes in PM 2.5 composition across space and over time. In addition, total PM 2.5 mass underestimates the amount of nitrogen in fine particulate matter due to filter losses. So we're happy to clean this up and share that with EPA, and I'd love to open it up to my colleagues. Thank you.
Thank you. Questions, comments from anyone? So that, as Rich said, addresses the suggestion about a total nitrogen indicator, probably in a way that fits better with things that are already being done. So we're done, or just people are thinking? Rich.
I just wanted to ask a question from the water guys. Was that just an example? Were you guys going to develop further for some of those other systems you mentioned? And then related to that, what about the Long Island Sound Connecticut River system? Is that one that?
Yeah, we talked about that. So I think we have to do some homework to see if that's available. It wasn't clear. Bob said that there are two different values depending on different sides of the sound, but we're planning on doing Mississippi River, Chesapeake Bay, Neuse. Am I forgetting another one? Yeah, White Bay. And then we'll look into Long Island Sound if the data are available. We'll include that as well.
I was just remembering quite a few years ago, Vermont was part of the Connecticut River Deposition Pact, and all the states got allocated their particular reductions that were required, and we had a huge required reduction in emissions from all of our direct discharges because we have the largest catcher's mitt in the basin and received the most atmospheric deposition, that they were saying that's your problem and you got to fix it by reducing your. So
yeah.
And Bob, you have your hand up.
Yeah, just to chime in, I think that's an excellent point. And we'll try to work that in. I'm a little out of date on what's happened there. And I think there, as Charlie just said, I think Long Island Sound's divided into half or two different TMDLs. So that would be the western, the eastern part, I'm sorry. We'll try to include that as well.
So any further discussion on the recommended standards? Go ahead, Bill.
Yeah, could you just repeat again, so your sort of bottom line number is, so for example, the EPA report was, well, currently 15 or 12 or 15 that might go to 12. And you guys think what again?
Okay, so I'm gonna have to remember all these numbers because some of them are proposed. And I will do my best.
This I would definitely like to see this on paper written down so I can think of that. Yeah.
Okay, so for the annual PM 2.5 standard, we are currently at 15.
Right.
And please correct me if I, missed something here because it's been a long day. And we are proposing a level of 8 to 10.
Great, thank you.
Okay.
Go ahead, Donna. Oh, thank you.
Is the floor open? So I had one comment that I wanted to get in, and that is about, in my comments, I tacked this onto research. It's not really research, but it's a funding issue, and other people have touched on this, that I just want to make it clear that all of these analyses, as you can see, depend on the national monitoring networks. And as Doug Burns just brought it up, that funding it's a perennial issue, and we couldn't do this work. EPA couldn't do this work. We couldn't have standards if we don't have the monitoring to support them. And CASNet is in danger of disappearing. So I think it's sort of, we're reaching a crisis moment here where EPA needs to, and I'm not talking to our people putting together the standards, but this is a message for the administrator, that he or whoever turns out to be the administrator at the time, needs to make monitoring a priority, and to live with this in this crisis situation, begging and pleading for funds to get data that are so important for human health and for ecological health. I just think is so sad, and I want to convey that message to the people in charge of the money.
So it sounds like that should go in our consensus comments.
I would really like it.
And it could go in as a separate topic. We have a few that we're accumulating. That sounds like maybe it's important enough it should be standalone, or it could be folded in presumably with chapter 2. But anyway, do you mind taking the lead on drafting something, and we'll figure out where it goes?
Sure, I'd be delighted.
Thank you. Yeah. Rich.
Well, just to build on that a little bit too, I noticed when Doug mentioned the loss of the ammonia monitoring network, and we talking about better indicators, we concluded that PMN was a much better indicator than PM. But over time, PMN is going to become less of a good indicator as SO2 and NO2 are further reduced, which you've shown by 2032 some pretty substantial reductions in sulfate and nitrate. As those get further reduced or decline, then PMN as an indicator in some point in the future becomes less relevant to deposition, and gaseous ammonia may be a far superior indicator if it has to be something that we measure in the air. So I think the decline of that network seems especially problematic, or maybe even perhaps other methods development to really characterize gaseous ammonia better, including remote sensing.
So it sounds like that needs to be worked in somewhere too, and maybe at least in the future section, because of this vision that we'll have to think about a different indicator in the future as the mix changes, is what I heard, right? Yeah. Bill.
Well, I think another aspect of what Donna just brought up would be the idea that with these networks, as we've heard, reporting at different time frequencies, at different periods of collection, there may be an opportunity to improve the overall utility of the network data products by reconsidering who does what, when, and how. In other words, you could imagine changing operational procedures at certain sites to enhance the interoperability and thus the value of the data from a given site. And if we're going to lose some sites, make the ones that are most important and most representative better able to be integrated into this continental scale assessment of air quality and welfare effects. So that was really striking to me when I saw the maps of this and the map of that, and these monitors here and those monitors there, and they all have important and useful histories, I would guess, but they were, as one would assume, to meet somewhat different goals. And maybe it's time to do a reassessment of the goals of each of these networks and make the overall effort stronger and perhaps more efficient. That would be my recommendation.
Well, that sounds like something that should go in the future research section, even though it's not really research in the same way, but it's a practical recommendation. Further discussion, Lorraine.
I really like what the Chapter 7 folks put together. It makes a lot of sense, and the rationale and for each one. And I think it's clear from all the evidence we're seeing that the current standards are woefully inadequate in terms of protecting ecosystems. I just want to raise, it seems like the Achilles heel in this thing is the Chapter 6 analyses that connect the ambient concentrations to the depositions. And we had a long conversation about that yesterday. And I can't, just in listening to it, I'm just wondering where folks are with that. I know there's specific recommendations for the analyses in Chapter 6 to address questions, and are there, given where we're headed with the recommendations, can we focus that really specifically of where's this potentially fall apart?
Maybe I can address that a little bit. I see that we had a lot of agreement, I think, on the data that were presented and issues with that. So I think there's a fair number of sort of details that, you know, we brought up that we'd like improved. And I see that there's sort of a split between the panel members about supporting or, you know, approving the method, this EAQM analysis that was, I see it as the sort of the primary analysis supporting the use of the PM, total PM as an indicator for deposition. Other people thought that it was not appropriate to have a method that EPA had developed themselves and not yet been peer reviewed, and they requested, you know, that much more support and research be done to provide that background. I mean, that's how I saw it. I welcome other people's input.
So it seems to me there's, to some degree, two things. One is what we're going to say in a consensus way about Chapter 6, but then there's also how relevant is that to the Chapter 7 recommendations, which I didn't hear you ask directly, but I think it's really important for this conversation. And maybe the people who worked on that could actually articulate that right now, how much weight you put on those analyses in your recommendations.
So in actually looking at the justifications for our recommendations, I believe multiple of the recommendations are based on data that are actually outside of Chapter 6. So I would say we really took into account the totality of the evidence, and that was, I don't know if I could put it like a percentage on, you know, what that weight was, but only to say that we were drawing on multiple bodies of multiple figures and tables throughout. And I think only one of these points or two referred to Chapter 6. Perhaps more. I could double check that, but I do feel that we covered the body of evidence that was presented in the whole document. So I feel confident with what we've proposed, but I'm happy to leave it to others to chime in.
Yeah, I think that's actually a pretty important point that we maybe want to articulate, given we've had some concerns about Chapter 6. The other thing, I guess, in terms of Donna, in terms of how we might write this up, I'm not sure anyone thought that the Chapter 6 analysis was not like, and I think everybody saw there was some value in the Chapter 6 analysis. I think we just came down on different places on the spectrum of how much to sort of trust it at face value. I think that's what I heard yesterday. And I think we all agreed that there were a number of technical details that could be explained better. But that aside, there maybe was a spectrum of perspectives on how much we trusted, even with those explanations. And Stephen, I see you turn your video on, so maybe you want to weigh in since you're on one end of the spectrum.
Yes, thank you. I'm not quite sure what I would recommend with respect to the analyses in Chapter 6. I really don't think that for a document such as the present one, these analyses, we analyzed this, we found that, we showed this, belong in such a document. But I concur with you that there is some value to the material presented. And perhaps a resolution might be to put the activities and findings portion of Chapter 6 into an appendix which then gets referred to, and perhaps some of the key results from the appendix that are pertinent to decision-making might be extracted and perhaps even repeated in the body of chapter 6, with the caveat that the material in the appendix has been conducted in support of this document, but has not gone through the peer-reviewed literature, but is considered of value with respect to the decision-making process. And that might allay my concern to a considerable degree of presenting this sort of material in the body of the document. I don't know whether that would be an acceptable resolution to others, but I put that on the table.
Any perspective, Alex?
Well, I don't have anything to add to that particular question, but I do think it's important to note that it wasn't all of chapter 6 that we were raising issues about. There were parts of chapter 6 that we were discussing, and so there were some analyses in chapter 6 that I don't remember or recall anybody raising any issue with. So just to provide context, it wasn't all of chapter 6. It was perhaps the high split modeling section that I believe I heard it was underdeveloped, if that's maybe the way we want to characterize it. So I just want to, provide that context.
Yeah, I concur with you to that point. It might take some work done with some delicacy rather than wholesale moving all those materials into an appendix. So I think whoever does it's going to have to pay some attention to what belongs in an appendix, what belongs in the body, and what findings coming out of the appendix also belong in the body. And I think one could do that fairly readily. The authors of chapter 6 kind of are the best people to do that. They know what they did de novo, they know what they did quoting the works of others, they know what they did quoting the findings of others. So they might be, if it were a recommendation out of this panel, I think they could probably do that readily.
And thank you. And I like the word underdeveloped. I think that's one we should capture in our consensus comments. And I also heard that it's not all the work in the chapter, but it's specific work that we consider underdeveloped and of concern because of that. So that should be very helpful to you, right, Donna and Lori? Is that helpful? You want to follow up?
No, that's really helpful. And I just want to say for the record too, that I think there's a lot of times when we're looking at policy questions that it requires quite a bit to connect the dots between what's in the published literature and the policy question we're trying to answer. And I don't think that those connections necessarily have to always be also in the published literature. I don't know where the line is exactly, but I think this sort of analysis is often needed to connect the dots, to answer the questions that are needed for this specific application. So I don't have any problem. I think that's what needs to be done. Yeah.
Okay, Stephen, did you want to follow up on that?
Yeah, I rather concur with that. If, for example, one used a well scrutinized published model such as CASAC to draw some conclusions and use them in support of such a chapter, I would feel much more comfortable with that. It's not a extract from a published paper, but it's using a published model. In this instance, it's a undeveloped, or to use the Leanne's phrase, model, and I draw a distinction there. So, but I think, again, I think the authors can better than anybody else recognize what fits in what category.
Thank you, Kathleen.
Yeah, I agree with both of those comments as well. And one way that might be useful to think about this is, for example, for Chapter 7, our recommendations are based on a subset of figures and analyses in the document. And if we think about what is the evidence that supports our recommendation and work backwards toward those critical analyses being at the front of the document and some of the others in the appendix, that might be a way to parse them. So the critical relationships that drive our recommendations, it seems to me, ought to be in the chapters.
All right, thank you. That's also helpful, Donna.
Yeah, I have another question for EPA. So my interpretation of the EAQM model was essentially that it was like a residence time, weighted residence time trajectory analysis, and that's been documented like in zillions of places. So I'm sort of thinking that you can come up with the citations to sort of support your model. This doesn't. I'm not asking, for a complete rewrite or, something brand new. I think just as the underdeveloped part is the documenting what you've done part, not redoing it in any fashion. So, okay.
Well, maybe I got a little bit lost, but I think I heard Charlie saying pretty strongly that there were some things that were made based on steady state assumptions, and the dynamic nature of things was such that the results were potential, what I would characterize as misleading. I think you said conservative. So that's maybe a bigger concern
for a different chapter, right?
Yeah, that is scheduled to go into the chapter 4.5. Yeah, I mean, models are always simplifying assumptions, right? So there's simple models and there's more complex models, and this is just pointing out a limitation of a fairly simple model that could be applied over many, many sites. So there are strengths and weaknesses to everything, but I think there's been quite a bit of dynamic modeling work that's been done over the last 5 years that could amplify and fine tune the story. So we'll try to add that into the report.
Okay, so it's my lack of expertise that attributed that to chapter 6 when it belongs in 4 and 5. Okay, never mind. All right, anyone else want to weigh in? On our agenda, we have an hour and 15 minutes left. Is there anything EPA wants to ask or comment on? Go ahead.
Yeah, I just wanted to clarify to make sure there's understanding, because I heard it mentioned in Dr. Pinette Gonzalez's comments reference to figure 625, and I tried to point out that figure 626 is the more relevant one to relate PM monitor, a regulatory monitor to deposition. The calculation, when it says weighted, that's which is what figure 625 is, it's taking all of the monitors contributing, via the high split modeling to a downwind ecoregion, and it's weighting them by their contribution to that downwind ecoregion. So it's not a value. Those concentration values are not a value for a specific monitor. It's a combined thing. So the use of that, so that tells you a lot, that figure, and people have commented on that figure. It's useful in terms of indicating relationships, but it might not have the predictive capability that perhaps people were interpreting it as.
Oh, did you want to follow up at all, Alex? Because Bill had a comment.
Thank you, DJ. 626 is better representation.
Okay, so 626 is better. So that's one clarification. And Bill, go ahead.
Yeah, I just wanted to make a general comment in response to that clarification. That's very helpful. I hadn't realized reading that that's how it was weighted. I could have, figured it out maybe or guessed or whatever, but I think it speaks to perhaps the analysis in that chapter in 6 isn't underdeveloped, but rather the explication is underdeveloped. And so I did go back and reread a bunch of stuff last night and this morning, and I'm much more comfortable with the 625, 626 figures now, that I realized that the fraction of ammonium deposition from TDEP, CMAQ, whatever predictions, it's like almost all ammonia. I mean, there's a very high fraction. There's a map, I can't remember the name with the number of it. Anyway, that then makes me say, oh, okay, I could believe that. That makes sense. It's not the environment that I'm used to working in, because I just work in a different place, not in one of these super high proportion ammonia. And so it's that kind of developing the storyline to explain this begets this is why we think that ABC is what's needed, because otherwise I stumble through and say, well, I know something about this stuff, but I don't understand this link. And so anyway, I wanted to say that I said before, I was like on the fence about this. Now I'm becoming more convinced that the use of the PM 2.5 for that context makes more sense to me, or is better supported now that I understand more the deposition regime that these numbers are reflecting across the US.
Go ahead. I think one of the things you said, Alexandra, was very helpful, was sort of totality of the evidence. And as you're providing the justifications for the recommendations, I think as often as possible, and as Karen said at the beginning of our conversation, we did a lot of different types of analyses, looking at remote sites 3 different ways. We looked at, near source sites 2 different ways. To the extent that you see evidence in multiple forms that are consistent with the recommendations that you make, I think that would be help us create a stronger case.
We'll definitely do that. Thank you for your clarifications.
All right, thank you. There's another point that I thought we should make sure that we're really clear on, and that is, are we going to ask EPA to bring us a second draft? And if we do so, we should have a pretty strong scientific justification for why we need to see it, other than we like to travel and meet each other and go out to lunch in North Carolina and, those things. But, and that we haven't gotten a chance to see some of the people on Zoom in person. Those aren't the reasons I was looking for, but anyway, I haven't heard any strong, compelling argument for us to ask for a second draft. But if we do have one, I think now's the time to get it on the table. Charlie wants to say something. And then Praveen after that.
So I've enjoyed this committee. I think it's been a good group, very serious. I think we've given EPA some, good recommendations, some positive things. I think it's really the way I see it. I think my perspective is that if EPA feels like they need us to review a draft to sort of, basically vet, what the PA to go to the administrator, I think I'd be happy to look it over, but, you know, I trust them and they want to do the right thing. And I think that, you know, I would be, you know, I would yield to their judgment in terms of whether they feel like there's going to be substantive enough changes that would warrant having the committee look it over. I mean, it really depends on what they do, right? So it's hard to judge exactly how this is going to play out.
I mean,
Yeah, I was simply going to say whether we want the second draft or not. I would think that EPA itself may want to revise this draft for themselves.
well, I assume the EPA will revise the draft regardless. And I mean, part of, I don't know exactly how it would play out, but if we made a really strong recommendation, that might be a factor in the court order deadline. I don't know how that works, but if we don't strongly ask for one, my guess is that given the court order deadline, we're not going to see anything because there just isn't the time. Oh, sorry, Hans.
You know, I'm just speaking for myself here, but, you know, I think I would certainly be open to any questions that you folks might have when you put the next draft together, because you're not going to know yet what we're going to be putting in the document, and some of it might be technically you need some additional input from us, if not verbally. And I would certainly be open to anyone contacting me or any of the folks heading up the individual parts of the report.
Okay, so I'm not hearing any, oh, Rich, sorry. And then Stephen.
Well, I wanted to bring up the point that came up yesterday about the new literature. And because of the long time delay between the ISA and the present, there's a pretty good body of pretty important papers out there that would be really beneficial. And it's more ISA type stuff, or a lot of it is. So I guess that would be one, and I don't know how that gets, or if it could get incorporated into a new draft or a supplement, but I think we could give a fairly focused recommendation for that one thing in particular that would be valuable. Now, whether that means we need to see it again or not, I think, you know, well, I think we kind of scrambled to come up with some numbers, recommendations here. And I think maybe those could be clarified substantially by seeing the results of some of that kind of analysis, perhaps also by seeing a little bit of expanded analysis and clarification of what's in Chapter 6 and so forth. So those would be reasons, and I think that they would be justified, as I said, largely by the time lag and delay, and then I like the idea also, however, of sort of leaving it up to EPA's, you know, decision of whether they think it would be valuable or no, because they're the ones who know how the court system delays work. But I think we could certainly recommend it, and that'd be my perspective on that.
Okay, so you brought up two quite compelling scientific justifications, which is the huge and far from normal lag in the literature due to the age of the ISA. And the second is that that seeing new analyses that support the Chapter 7 recommendations would be definitely value added. So those are two pretty strong scientific recommendations. I also heard you're saying, consistent with other people, that we don't need to demand it, but we could recommend that we could invite EPA to requested, is I think the way it's being framed. Stephen, did you want to share your thoughts?
Yes, thank you. I would certainly hope that in the revision of the document, EPA will take into consideration all of the submitted comments from the members of the panel. And I would more or less trust them to do that. And also taking into account the discussion that we had yesterday and today. I think it's much more important for this panel to review in some way any changes in the recommendations that for standards that might come out of their consideration of what we've had to say and what we've submitted. Its bottom line is that the administrator is not going to read the whole document. The administrator is at best going to read the recommendations that come out of this document for standards, any changes in standards that come out. And so therefore, I think it becomes really important for this panel to review any changes in recommendations in the revised document relative to the document that we've seen.
So let me clarify, are you thinking we need to see any changes relative to what's written in the current document or relative to what we are recommending now, which is not what's in the document?
Well, my assumption is, perhaps incorrectly, that EPA is not going to accept every recommendation that our panel has made. If they did, then I don't know that we would have to review those changes. We would say, great, send it up to the administrator. But if there are any changes or are not any changes in the revised document relative to this draft that we've seen, I think that's important for this panel to know and understand the reasons behind it.
Okay, let's see. Davin has his hand up and then Praveen, and I'm still not 100% clear, Stephen, about your answer, but maybe we'll circle back after the other discussion. Go ahead, Davin.
Sorry if I wasn't clear.
Yeah.
Thanks. Yeah, I guess I would just like to reiterate what a few other people have said a little bit, which is I'd be certainly open to reviewing another draft and interested to review another draft, depending on the level of changes made by the EPA, particularly with regards to the levels of the indicators that we're proposing and discussing in Chapter 7. And we have kind of in our short meeting scrambled to throw out some numbers, which I think are good ones, but we're also asking the EPA to probably spend a little more time on that and be interested to know what they find. And if, for example, they find that in order to substantially mitigate the adverse impacts of nitrogen deposition, they need PM 2.5 standards that are even lower than the ones that we suggested, maybe even lower than the primary standard. That's probably a pretty significant deal that they could use some backup from CASAC on. So that's a hypothetical, but again, I think it's something that I'd be willing to take a look at, review, certainly interested to, and it does at this point, I think, fall upon the EPA there to make this connection between the levels that they're proposing and the amount of welfare benefits that would be achieved. I feel like we're kind of asking for like a regulatory impact analysis, which is a step we don't have this cycle, and that's really perhaps unfortunate, but that's what we're looking for here.
All right, thank you. Praveen?
Yeah, thank you. I heard Steve and I started thinking, the appropriate role for this panel, appropriate role for EPA staff, and an appropriate role for EPA administrator. And the draft report makes a point, if I remember right, a number of times, it's a judgment call, and judgment is made by the administrator. We simply make scientific recommendations, we go through staff, and I guess meets Mr. Reagan and, makes recommendations. So if your recommendations are more or less the way they are now and not say impacted by what we did here in the last 2 days, then it's not clear to me. Maybe we need to meet, at least see what the recommendations are, and maybe reserve the right to make some comment then. I mean, we went through this exercise in 2012. We did all this, and then EPA administrators said, too much uncertainty, in my judgment, and that was a judgment call. So, there could be judgments called here, and that's why Mr. Reagan gets paid for what he does. He makes judgments. And we, I guess, simply advise and suggest and recommend. So I don't know what our options are down the road.
I mean, once we are done and don't see another draft, then we're done with the process, and the administrator makes their decision based on criteria that don't include encompass our scientific advice, I think is more accurate way of putting it. I don't know if EPA wants to weigh in on any of this conversation. Maybe that would be helpful at this point.
Maybe just to clarify, CASAC's advice is very important to the administrator. And one comment in terms of the logistics of the final PA is that we always include a section which summarizes CASAC advice and cite to the letter which goes to the administrator. You all send a letter to the administrator. And in pulling, in briefing the administrator on options through the regulatory process, and in him making his decision, he considers CASAC advice. That is the reason CASAC, or the body that is CASAC, is part of the Clean Air Act requirements. So it is very important to the administrator, and he must consider it.
So I guess I heard, I guess overall, I haven't heard a strong consensus that we should demand to see a second draft, although thanks to Rich, we have some good scientific justifications for asking for one. I heard a lot of openness to it, and we've had an interesting conversation about if the further analyses or EPA's further work leads them to different conclusions than we have reached, what's the value of us asking for another review in that case, is I think what I'm hearing. If EPA's conclusions differ from the ones that we have reached today. Is that right? Is that what I heard? Did anybody else interpret it differently? Rich, you wanted to say something?
Doesn't feel right to me. I would say if they reach conclusions that are vastly different from ours, that would be the reason we'd like to have another look at it.
Maybe I misspoke. That's what I meant.
Oh, okay.
Yeah, if they agree with us, we don't need to see it again, I think is what we said, what I was trying to say. As opposed to they keep it the same as it already is, that would be pretty different than what we've concluded. So, yeah, we could recommend that if there are large deviations from our advice, that given the big difference in our recommendations versus what is in the draft and the considerable lag in the literature, that those are two very strong scientific reasons for looking at it, and then additional analyses that should be done to support whatever recommendations. Okay. Anything else? Rich.
I had two things. One is, I don't know that we ever really finalized our thoughts on research recommendations. That seems like it ought to be a group topic. Maybe even we could all send them in to you and you could synthesize them and
Alex. She's responsible for that question. So I heard a couple of things, and hopefully Alex was taking notes during the meeting yesterday as well that, you know, are relevant. And certainly people should submit, and you will also have opportunity to review the full report, and we can make changes, but it is always better to have as much of it finished as possible. So we're not repeating some of our recent experience doing wholesale changes of our report. Yeah.
Yeah, and then I don't know if we're getting near the end, but I did want to raise one sort of issue out of left field that came up earlier, which is there is certainly for a lot of these effects, a lot of spatial variability in the inherent sensitivity of the ecosystems. And we see this in the variation of critical loads in different ecoregions, east versus west. And that seems like something that would be valuable if EPA, with our help or not, could come up with some ideas of how that kind of spatial variability in the inherent sensitivity might be addressed, given that it has to be a national standard. But you figured out ways around that the last time. And, you know, could there be ways to just even divide things east versus west, or somehow have it be relative to exceedance of critical loads, and then that would separate regions out? I know that makes things really complicated. One time years ago, I think it was a PM review, Ellis Coling and I came up with the idea of, what if, since it's a secondary standard, could it be a progress-based kind of a thing? Very much as the regional haze rule is a progress-based kind of a thing. And that really would accommodate, you know, all the regional differences. And we were told by the EPA lawyer at the time, no, we can't do that. But still, I thought I'd just raise that topic again. Maybe also it's way out of our bailiwick. Maybe it's an implementation thing, but it certainly would be something that, given there's no time frame for the attainment of these secondary standards, that different regions could approach them at different rates or something like that. Anyway, I thought that was something we kind of missed.
So to follow up, any comments from EPA on this?
I mean, I guess I just want to comment that generally speaking, that's how implementation works, right? It's like the severity of the problem determines the length of time you have to solve it. So.
And we heard some discussion about there have existed standards that are end up varying over space because of how they're because of how things are calculated. Is that right? Didn't we have a discussion about that? Again, outside my expertise, but Rich, you were reminding me of that, I think, earlier too. Microphone.
Just if we look at the patterns of deposition of nitrogen, there's large spatial variability in that. There's large spatial variability in the deposition of sulfur, the things that we're most concerned with. That's just the variability in the deposition. And then there's spatial variability in the inherent sensitivity of ecosystems, higher elevation, surface waters and soils in the Western United States, you know, that haven't been historically exposed to the same kinds of levels of SNN deposition as Eastern sites, are much more poorly buffered, and so forth. So, I mean, again, that was something that I believe was accommodated in a clever way by the last review in the aquatic acidification index. So I'm just not sure. I mean, I was amazed that you were able to do that last time, and I don't know how you could do it again, but I'm just throwing that out there that, as a concept.
Deidre, were you gonna make a comment? So.
Yes, thank you.
Stephen, go ahead.
Oh, I'm sorry.
Good.
We had asked whether the standards have to be uniform nationally, and got the answer yes. And we had asked whether there can be within the current legislation a deposition standard as distinct from a concentration standard. We were told no. But I'm wondering whether this panel might recommend, or whether EPA might recommend, the EPA staff might recommend to the administrator some consideration of changes in the legislation, I guess, that would permit different standards in different locations, or that would permit deposition standards. I think this panel, especially from what Rich just said, would probably feel that, yes, it makes a certain amount of sense to have different standards in different parts of the country. And I got also the sense that this panel, with the focus on deposition, might think that deposition standards might make a lot of sense. So I don't know whether it's appropriate for this panel to recommend consideration of such on our own say so, or to recommend that EPA staff include perhaps a statement of recommendation of consideration of such changes, or a statement simply that the panel recommended that without necessarily endorsing it. But those are just a couple of thoughts I had on that.
Thank you. Rich, maybe in our growing list of things that weren't in the charge questions, you could try to articulate, I don't know whether it's more of a future research topic or just a suggestion, because it seems like this is scientifically very important. And if there's some way, some creative way in the analogy of that aquatic acid index where there could be a uniform number that somehow results in different amounts in different places, that would be, I think, value added to think through how that could happen.
Then I should have gotten Nobel Prize in regulations.
Could you repeat that?
I said that was the beauty of the standard, because, and I said it should have gotten some kind of Nobel Prize in regulatory innovation. Just kidding.
All right. Stephen, you have your hand up again.
Yeah, thank you. I don't want to monopolize this discussion, and I know we're running short on time. I'm not sure we ever got an answer to the question of exceedance of PM standards, for example, by the smoke coming from Canada. It's not something EPA can do anything about. It's not something that local air pollution authorities can do anything about it. It's there. We're in exceedance of standards by a substantial amount. How does EPA deal with that? Is this something that they say is out of compliance, or do they say no? There's an exception for these kinds of things. I don't think we got an answer to that.
You want EPA want to respond to that?
Sure. I'm sorry, I didn't realize that was a question before, but so it's treated as an exceptional event, and the Clean Air Act makes allowances for exceptional events that can't be controlled. So that's how the Canadian wildfire impacts would be, looked at, or wildfires within the U.S. And there's a whole, process that one goes through in establishing what becomes an exceptional event and how the data gets not included in design value calculations. So,
and just for Stephen's information, several recent CASAC reviews have made the argument that wildfires are no longer exceptional, and so that should be revisited. So I don't think we provided any concrete advice about how to go about that, but scientifically, we no longer think that wildfires are exceptional. They're much more routine, so.
I'm afraid that is the case. We're not talking about wildfires necessarily. It could be a volcano. There's things that are just outside of EPA's control, and somehow I think that one's dealing with PM standards. There should be an asterisk that says except for, and as that lets the local agencies off the hook.
Yeah, well, apparently that is the case. So, so we're basically, I think, wrapping up a few minutes early. Lorraine wants to make a comment.
Just one, and it's a question I don't, when talking about the possible, the recommendation that a standard should be deposition based, Rich reminded us that under the Clean Air Act amendments, there was a feasibility study that was mandated under that to consider the possibility of and I don't know what's possible to, a feasibility study was done about the possibility of a deposition-based standard for protecting ecosystems, and was at the time, I think, rejected because too much uncertainty, but I don't know if we want to say, raise the question, could that be reconsidered under those amendments? I don't know what's possible there. It's different than that's outside our purview here because it's not part of the NAAQS process, but.
I don't know if we have an answer for that. Does anybody have an answer for that?
Could we include that as future research?
Sure. You want to make sure that that gets to Alex, or I was looking at Lorraine, but either one of you. So Aaron wanted me to make sure that we were clear on the extra writing assignments. And I also thought it would be worth reiterating what I heard, where are my notes, about our advice about the second draft. I heard that we would welcome a second draft, and we really only think that we should see one if EPA decides to deviate largely, maybe we can think about the word we want to use, from our recommendations that were put forward by the Chapter 7 group. Is that the consensus? That otherwise, we welcome one, we'd be happy to provide additional input, but given that the lag in the literature and the need for developing additional justifications for those recommendations, even though we provided a lot of support from what's already in the document, that those are, if there's a big deviation, we would like to see another draft. So that's what I heard, and that's what I think we'll go forward with. And then for the extra writing assignments, let's see what I can remember from, I know Lorraine isn't taking the lead on uncertainty, and Charlie's taking the lead on the deposition. And there was at least one or two others that people were going to take the lead on. Network funding, Donna was going to do. It seems to me there was one more. Stephen.
Yeah, just technically, I'm surprised we haven't heard from Aaron on this. I would expect he would be telling us that any correspondences about these matters, either between a subset of ourselves or with EPA, he should be getting copied.
Yes, he should be, and he'll probably remind us before we close out on things like that. And Bob, you have your hand up. Maybe you were the one that was going to do another one.
Well, there's a bunch of us from the aquatic group looking at, in particular, coastal systems. but I'm taking the lead on that together with Hans and many others.
Yeah, thank you. That was, I think that was the other big one. Thank you. Was there one on ammonia? Thank you, Aaron. Were we going to have any separate writing on ammonia? Or was that Hans who just left who was going to do that? Anybody remember if we were going to provide? All right. So any last anything? EPA?
Yeah, we just want to thank everybody. I know that it's a lot that we put in front of you, and that I know we not a very long time to do it. And so thank you so much, and thank you for all your time the last couple of days. It means a lot. We really appreciate it.
Thank you, and I thank everybody. I've learned a tremendous amount, not being a secondary person. So I've learned a lot from all of you.
You are not a secondary.
By no means a secondary panel.
All right, so I turn this over to Aaron to adjourn us and also to remind us of all those things that we should remember. And you will also follow up by email, I'm sure.
Yes, so again, FACA allows small subgroups to work together as long as the results of those small subgroups are discussed in public. So that's what we will be doing. Your lead discussant, lead author, subgroups will develop drafts, and you can float that around among your lead discussants to make sure that everyone can weigh in on that to capture these consensus responses during the meeting. Leanne and I will assemble that report, and that report will be discussed in public during our next meeting, which I believe is in September. It hasn't officially been announced yet, but we have scheduled that. And so among your discussion or your email for developing those, make sure to CC both Leanne and myself. And Steve, we did discuss this during the administrative meeting. So just FYI, we did remind them yesterday. And then I'll be in touch with deadlines in terms of when those responses will be due. You will also have an opportunity to revise your individual comments. So as we discussed yesterday, again, during the administrative meeting, the report is in 3 parts. It's a letter to the administrator, which is a synthesis, a distillation of the consensus responses. Then there's the consensus responses. Then there's your individual comments. So most of you have sent in preliminary comments. You have an opportunity to revise those and finalize those, and those will go into the final report as well. Any questions on that?
In September, is that remote or?
Yes, that will be over Zoom. Okay. Yeah, and we'll provide further details later.
Is a subgroup of 8 people okay, or should we?
Yes, so the total number of panel members is 18, so no more than 9. Okay, so if there are no further questions, thank you again, EPA. Thank you, members of the public who have participated. Thank you, all your panel members, for your public service, and we can be adjourned.